Hello, I hope there are no mic issues. Oh, the train is just going to play right at the beginning. Let me go ahead and hide that. But yes, wrong mic. Are you... Okay. Linux, you're driving me nuts here. Come on.
That one. Okay, how about that? That's gotta sound better. Oh, man. Audio fixed? Okay. That's gotta sound a lot better. Hello, Helicroft. Hello, Hiram. Hello, Lady Ironborn. Hello, Ben Mad Dog. Hello, Spies of Mud. Hello, Dutch Black Cat. Hello, Killers993. And hello, Taters Games. I hope you guys are having a good day. I'm having a pretty good day here, and I'm pretty excited to continue on with this project. So, let me bring this down. We have pretty much the exact same stuff that we had yesterday, but I have made a couple of tweaks. I swapped the fan, because that was excruciating yesterday, so we won't have to deal with that for today. Somebody did get the fans for me off of the Amazon wish list last night, and I'm extremely appreciative of that, so we will be replacing the fans in here eventually. So, yes. Are you going to work on reconditioning caps today? Hopefully. I finished the VOD from yesterday 2 minutes ago. Man, you timed that perfectly, Helicroft. Ben Mad Dog, if that was you, thank you. Oh, man. So that shouldn't be as bad, but I've also gone ahead and made some actual power cables to use with this thing. So these are on one end, just stranded wire that I can crush into the screw terminals, and on the other end, banana jacks. And I went with banana jacks for a couple of reasons. I was torn between going with banana jacks or clips, but you can always clip, like go point to point clip. I should have some of those somewhere, maybe not. I might be making some of those today. You can do point to point clips from banana jacks, but you can't plug a banana jack into a clip as easily. So I went with that. Hello, Portizo. So I did that, but I also, after looking through the manual last night, made this, some sense. You know what, I'll just switch to this camera. I made some sense wire connector clips that are twisted pair, so that they should not have as much signal degradation. And I'm going to be connecting these so that I can plug into the source and do proper measurements of this stuff, and we'll see if maybe that does a better job of doing the current calibration by eliminating the wire losses. Although these wires are ridiculous gauge. I don't remember if it actually says on the sleeving. No, the sleeving is just plain black. But I found, this is what I made it with, my spool of really nice automotive grade Radio Shack wire. So this is 10 gauge stranded wire. It should be low enough resistance, but we'll see. Hello Valiant Seed, and hello, I'm Starhawk, especially since it's your first time chatting. And hello Grisgore. So, I have a couple of objectives today. For one, if we do exclamation point code, I added this last night. I've created a GitHub repository that you can look at to see what I'm working on here, and I will go ahead and switch to this so that I can show you. Bring it over here so you can actually see it. So I've gone ahead and started a document that goes over everything that I'm working on, links to manuals and other things, and has the basic commands that I'll be using for all of this stuff, so that I just have everything I need right off of the bat. I worked on this last night. Wow. Okay, hold on here. I'm gonna go Sari, since you have that in English. Thank you for the Prime sub. But I got some other things I need to do here. Hello, hello Sari, first off, since it's your first time chatting. Hello Fizzlewop, since it's your first time chatting. Yeah, thank you. So shouldn't this be on CapsWiki? It will eventually, Hiram, once I have this more finished, and that was the wrong thing. There we go. Once it's better done and laid out. But for right now, I'm working on code. That's what I'm going to be doing. So I'm going to be writing a Python program today for automating this. So, see, Shelby, you know me from YouTube comments and email. I'm the one named after 1997 sci-fi movie starring Mark Hamill that kind of bombed. Loved it though. I can't remember. My apologies. See, last 4 days of Pentium Pro for you. All right, no problem. See, last day tier 1 switching to Prime sub when it becomes available. Makes sense. So what am I talking about here? Oh, one thing I'm thinking about doing as a test. So I have here a gutted ATX power supply, but on this thing we have 2 fairly large caps, and I know for certain this has not been plugged in for a while. So I'm guessing that these might be a good candidate for just doing rough test reforms today. And I like that there's 2 of them, that they should be the same, so we can check some things. So I'm probably going to be removing those and working on the test today. Laserhawk, okay. So that's probably going to be my main test bed for today. However, that's not the only thing I have. If I move all of that and come over here and break my back a little. Oh man, I grabbed one of the CompuPro's 8-inch floppy drives. Boom. And we might be, if we looks like we're getting close enough to being able to run an actual reform test, opening this up and looking at some of the capacitors in there, because I really want to do that, and get this thing working, because that's kind of the goal here. First is to get that going so I can start imaging floppy disks. So yeah, 2 8-inch drives be 16-inch. I mean, kinda, yeah. But it's really weird. I didn't notice this until I moved this in here this morning. This actually has a CompuPro sticker on the back, which is just cool to see. So yeah, lots of stuff going on here. Hello, J-Metal. Yeah, you might enjoy that. Interestingly, I noticed something, J-Metal. You have the 8-inch drives. I'm really not going to be able to show you this well. They have the LED in the button. I have a pair of those out there, but they're separate from these, and I'm hoping that those were used with the IMSI because I don't know which pair of drives actually were, and since these have CompuPro stickers and there's 2 of these, I'm hoping it was the other one. But there's a very real chance that I just don't have floppy drives that go with the IMSI because I have a 5th drive controller. Actually, I have 2 5th drive controllers in the other room and the manual for them, but I don't have the 5th drives. So I don't know what I've got and how well I can get this all going. So yeah, interfacing a Laserdisc to the MSI, that would actually be extremely easy, Hiram, because I have a, oh man, I'm gonna mess up the model number here. I wanna say a KV4400. It's one of the floppy drives that the Doomsday Project, Laserdisc players that the Doomsday Project can actually interface with, but more importantly, it has a serial connection and supports LD-ROM. So it would actually be possible to connect it directly to an MSI or the CompuPro, either one, without weird stuff going on. So, yeah, 3.5-inch floppy drive would look tiny in comparison. I think I have one over here, maybe. It would be, I got it, well, okay, here we go. That's a 3.5-inch drive. Pretty great. Dual drive runs the CBM 8040 drives. I can tell you this thing is way more massive. I have one of those, so yeah. I could play Dragon's Lair almost, sort of. See, of course you have one of those. Yeah, I do have one of those drives. I keep meaning to actually buy the parts to do the Doomsday Project thing because I have a sealed copy of Family Dog by Steven Spielberg, and I want to rip that before bit rots, and I know that that'll be as good of a copy as it can be possibly attained, and that show was only released on Laserdisc, and I absolutely loved the Super Nintendo game when I was young, even though it's kind of like a garbage tie-in game. It's way better than it has any right to be. So yeah, see, But yeah, so wonder if you could potentially archive data with the 8-inch disc. Yes, amid Weasel, that is exactly what I want to do. I'm estimating now that I have over 500 of these and a lot of software ones. Like, just give me one moment. I'll be right back here. So with the MSI and CompuPro stuff, I got a ridiculous number of 8-inch floppy disks, and I have things like this. This is a complete set of CompuPro concurrent DOS 816, and this is version 3.1. And I don't believe there are proper disk images of this or any of these other commercially produced software programs I have in here. And I want to image all of these with the CryoFlux through one of these drives, because if those discs go bad on me, or maybe someone else needs one, like I know J-Metal, who's commenting here, could actually benefit from this, it will be important to get those backed up. So that's my main goal here with all of this right now. Data General, I can back up that stuff too if I can get this working with the CryoFlux. So that is the main thing that I want to do. Yeah, Shelby's cornered the market on 8-inch floppies. I genuinely wouldn't be surprised if I have some of the, I wouldn't be surprised if I have the largest private collection of 8-inch floppy disks right now. I have too many, but they all are written. So it's not like, you know, I can start redistributing them. They all have stuff on them. It's not like new ones. So see, my disks that I was trying to restore are 4.1, but I think they're the same bootloader as 3.1. Interesting. Yeah, I have no idea how that works, but once I do like sector level archiving of them, you might be able to try swapping bits around. So yeah, we'll see how it goes. See, preservation of media is always important. Yeah, I have so many of those 8-inch discs now that I'm thinking about, once I get this sorted out and can start ripping stuff, that we might just make one of the stream days purely about archiving media. Another thing that was picked up for me off of the Amazon wish list is something that I've needed for a while. It is a USB cable that plugs into this camera, which I can then set up with the Lightbox TV that I made here. I'm all building towards a specific goal here, to create a stand area that I'll probably put on the workbench I have over there, where I can just rip the media in a drive and then take it over and photograph it with the camera set up and pre-exposed and all that stuff. And then it will transfer the pictures directly to my computer, where I can then just zip the whole thing, upload it straight to archive.org in this whole workflow where everything happens bam, 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 and that's my goal. So I really want to work on this. I missed something. By the way, did you see my email about the compact parts, etc., that I have to send you? Email, compact parts. Okay, yes. It was, yes, you had an update about it, yeah. I need to read both again to refresh myself on what we were talking about. I did briefly scan through that, but yeah, as I'm getting home from the streams at night and I'm basically crashing, weekends have become not the best way or best time to get a hold of me. I was planning on looking at that probably tomorrow morning when I'm all bleary-eyed after today and responding to your email and a bunch of other things. So yeah, I will get back to you. So, but yeah, thank you to do that. And yeah, I'm very happy with what Grisgor's suggesting there. Make all those silly predictions that you want, because I'm not always thinking about that kind of stuff. So if I win a fortune in the lottery, I'm going to start a company to manufacture CRT monitors and 8-inch floppy drives, just because CRTs would be really good, because they're dying now. So no worries, ignore the first email, the second supersedes it, kind of cancels it out. Okay. That reminds me though, I know you're mentioning some PC 104 stuff. I found my PS2 multi-input cable for my 486 board, so now I can connect a mouse. That's nice. I was very happy to see that. I was looking for something else that we might get to later today that unfortunately I didn't work out, but yeah. So, okay, I should take this off because we're not getting to that for a while here. And then we can start to do some stuff with the test gear and see what kind of progress we're making on that. Because I'm really excited here about all of this. I haven't tried this yet. Oh, that's so much nicer. Oh, yes. No screeching fan. It's still loud, and it'll be better tomorrow. Whenever the fans get here. Speaking of loud, that floppy drive is disgusting, and if we actually start working on it today, I'm going to be trying out something that I bought, and I'm not sure how well it's going to work out. I'll just introduce it now. This is an ESD safe, supposedly, vacuum, and I'm glad to have picked up one of these because I need to clean off all of the cards and stuff from everything. So if we take a look at the front panel for the MZI really quick here, you can see that's a clean spot that I wiped with my finger, and just how revoltingly gross all of this stuff is. All of the S100 cards are like this. So I need to go through and I need to actually vacuum clean them. So I have an ESD safe vacuum, but it came with some bristles and tips and stuff that I don't necessarily trust. So I'm actually trying to get some ESD brushes. Those should be on the way. I was hoping to pick those up yesterday, but the mail didn't work out in my favor. But eventually I'll be using this to clean all that, hopefully. I'm probably going to try and make it even more ESD safe by adding a ring of copper tape inside of here, and then having it have a wire that comes out and runs down to this, and then grounding to this. This is actually, I believe, grounded on the lid here, so I can tap into that, which is really nice. You can see there, but that is a whole thing I'm working on, and the main reason I'm bringing this up is because I bought this thing, and the reason that I bought this was because I couldn't use an air compressor because air compressors are really loud, and I didn't want to be annoying my neighbors all the time. But this thing ended up not being tremendously quiet either. So I'm not sure how bad it's going to be in here, but that's pretty loud. So I'm still working out my plans on what I'm going to do to maybe make this a little quieter. Obviously, I'm not going to be able to put an aux in that to make it quieter. So I might build like a foam enclosure that I can stuff down there, because the way my workbench area is set up here, I actually have some empty space back behind the workbench, a considerable amount actually. You can kind of get an idea of how much is back there. So I'm thinking I might build like a foam box that goes over there, and then put this in that with like vents on the side so it can still pull air through. But yeah, that's it's pretty darn loud. So I don't know, but we might use this to clean the floppy drive's exterior today because it's extremely gross, and every time I pick it up it ruins my shirt. So yeah, so miniature shop vacs in terms of sound, yeah, that's basically what it is and what it needed to be, because it's going to have to be really high power to do what I need. It comes with this thing, which is kind of nice. It's a vacuum tip that you can put a brush in, but I don't, again, know if this is actually ESD safe. But the vacuum cleaner is, and I kind of believe it, and it seems to be well made. So I don't know. I might trust some of this, but I'm not sure. I might want to test it on some other stuff that is less rare first to see if it survives being used with that. But okay, you need to nickname that vac loud, Howard. Oh man, okay. Let's see. I have IMSI and Nova 2, both of which you need to fix. That is really awesome, Jout76. Everything I'm doing here with the IMSI and the CompuPro stuff is going to directly benefit getting to the Data General stuff, because this is all the same kind of thing that I need to work on. It's just the IMSI stuff is not as rare, so it is lower pressure to work on, because if I make a mistake, I actually have a lot of extra parts. Like I have 2 of those floppy drives, and then I have a ton of S100 cards. So I could potentially make a mistake and not have it be the worst thing, but also worst case, there's more S100 stuff out there. It's expensive, but I can actually find it, unlike the Data General stuff, which I've been looking for 2 years and have seen none of. So yeah, that's why we're starting with that now that that's an option. So okay, let's get everything connected here. I made these wires. I haven't actually tested them yet, so I need to get that done. Let's go ahead and get these connected to the back of the power supply here. All that worked out. You can actually see what I'm doing from the other side. So the power cables are actually, you know what, I can feed those through the wire rack mount stuff. That'll work out well. Power cables are stranded wire that I can then crush into the screw terminal, so hopefully that'll work out well. But then the sense wire I made it ends in a standard connector type thing, and I'm hoping that I can just plug that into the little jumper wires I have back there, which won't be ideal for signal integrity, but I think it'll work out well enough. Hello, Brian the electrician. Wash the boards instead of vacuum. So the thing about that is that I don't have running water in here. So I would actually have to take everything home, wash it at home, and then bring it back, and I can't bring all of my filming equipment back and forth with that stuff and do that. So I really have to have a dry cleaning solution here, and I'm pretty sure vacuuming will work. So that's why I'm going that route. So all right, let's get this stuff plugged in. Undo the center ones so that I can plug in or connect, not really plugging anything, the other wires. Do these come out to be crushed down? No. So these could really benefit from having washers on them actually to more evenly distribute the pressure. Oh well. Let me plug this in while I'm at it though. So this is plus, I'll go into red. And then this is minus, goes into black. All right. So for minus, here, you know what, I'm gonna do these from the top. Oh, that sucks, that sheared. That's gonna make this a little more difficult. Oh, these are thick wires. Whoa, okay, I may have to split this and go around both sides actually. Wanted something that would definitely be enough, and these are also kind of just what I had, so that's what I have to use. Do need to make sure this doesn't touch the sense probe over there though. There we go, that's extremely solid. Go ahead and split this. Need to back that out more still. Good grief. Big wire. Okay. There we go. Oh, that one's going to mount really, really nicely since it still has the separators. Oh yeah, that's dramatically better. Okay, significant improvement. Okay, let's see. You haven't seen thick wires till you've done 3,000 amp service. Whoa. Yeah, that's a lot. Let's see, maybe look at arrow. All right, got some catching up to do here. I'm trying to click the thing here. Okay. Let's see, okay. Hello, X down set X, since it's first time chatting. Maybe look at California Air Tools compressors. They have some that are rated at 70 dB. We have one that you can comfortably talk around. I have used some nice quiet air compressors. The other problem with that is, while I could actually use something quiet like that in the office place without it being an issue, the other problem is the ventilation in here is terrible. So it really, I would kick all the stuff up into the air and then it would just settle down. So onto the ground and things around here. There's nowhere that I could really do that. There is nowhere outside that I could really use an air compressor. So unfortunately, it's just not an option here at all. See, some nice fork connections would be better. Yeah, I tried to find some, I couldn't. So I basically made fork by just splitting the strands. Yeah, I tried to find some of those, but oh well. Sweet, to be honest, I feel a little left out. All this cool tech and all I got working is C64. Yeah, I've spent a lot of money and time picking the exact bits of hardware I have here, and then I've spent years looking for stuff religiously, nearly, trying to build up the computer collection. Not really trying to build a collection per se, but just keeping an eye out for things that I'm interested in. So it's been a long time. It's taken me a long time and a lot of money to get to this point. So are you going to use the music keyboard during the stream? No, Bob Cobb. It's just, it's over there because I used it on stream one time and haven't brought it home yet. So, what's the big blue dongle? Lazy Crypt. That is the USB GPIB interface that I was sent by Randall in the last stream. And I didn't thank them again at the end of that stream, and I'm very appreciative of it. But that's what's allowing me to connect all of my test equipment to my laptop that I have off to the side here, and it's extraordinarily helpful to be able to do that. So let's see. Bring back beige computers, yeah. Let's see. Had to run 2 solid bars of copper for superconducting magnets at work. Man, that is an interesting problem to have to solve. Depending on the dust, you may need to do some degree of wet cleaning. If it's been stuck there for a long time, could be stuck on. Yeah, I am thinking that that's potential, and I might get like just damp paper towels to do that. I don't know yet. So, going to start your own museum. That might be Office 2.0. I will look into that as an option depending on how everything goes between now and the end of my lease, which I signed a 3-year lease, so it's going to be a little while. I will probably move at the end of my lease for a number of reasons. I don't really have any problems here. There's just some things that are not ideal, but overall it's fine, and I'm going to be fine here for the 3 years. It's just, I think I might be better off moving at the end of the lease, but I'll see what happens. See, cordless compressor, perhaps small but effective. Yeah, so there's like the data vac. Again, I have the same problem though, that I'm just blowing it out into the office because I have, I really cannot work outside of the office. I can't stress enough that there's nowhere outside of the office that I could comfortably work. There isn't like a back patio area where no one goes. There's only main entrance and that's it. And I can't do that where I am. So yeah. See, imagine having the USB GPIB opens up a lot of possibilities. So many possibilities. I can do everything now. We're going to be logging voltage and resistance with this. We're going to be controlling the voltage and current on that. And then later on, back there is my, if I click the thing that lets me change, is my oscilloscope, logic analyzer, all that nonsense stuff, where I could log frequencies and waveforms and all sorts of stuff. So yeah, so, sorry Shelby, I mean those from 18-volt drill. Yeah, I do know what you're talking about, Montreal, but again, I really don't have anywhere that I can go work like that. I mean, I could go out there for like 5 minutes and do something, but I can't do the bulk kind of stuff that I have. There's nowhere I could go set up a table and work on things outside, so yeah. An idea I had for a point where it was 3D print something on stream. The thing about that is it takes a lot to set up and maintain the printer. I've thought about that too. It would be cool. And I was also thinking if the point reward was high enough, or maybe a bit reward or something, that it could be something where I mail it to you afterwards, but really maintaining the printer and doing the stream at the same time is very difficult and adds a lot of overhead. If I was, say, streaming, this is gonna sound insane, if I was streaming for like a 10-hour block, like guaranteed, then I could do for like the first 5 hours, maybe you could start one, but that would be about the only way that it would make sense to do it, is because I would need a lot of time to be able to do everything. So, see, and we need a screen overlay on stream with real-time measurements. Yes! So I actually have an idea for that, Hellencroft. I'm doing this with my laptop, but I realized that OBS can read files in real time. So you know what? Let me try this really quick here. I am going to go to my home directory. I'm going to have to actually use the keyboard connected to this. Actually, let's do this here. I'm going to do it on this thing. Actions. Oh, I can't just, okay. Vim volts dot txt, and then I want to write 1937. Okay. So let's right quit that. Okay. So what I'm going to do, excuse me, I'm going to add a text overlay real quick here. Add text, say volts. Okay, read from file. How do I pick the file? Because I know OBS has this. How do you do it? Do I have to write the path to the file in here? That how you do this? So if I do copy, paste, see if this will work. Okay, let's do that, and then why is it all weird? Okay, so that's the path to the file, but then it's not like reading the file. Boom. Let's see. Counter argument, regular print jobs could possibly reduce maintenance overhead. Yes, but it's like the filament changes and then my filament's all old. I don't know. I don't think that's going to be a good thing because I got to add a whole bunch of other work that I have to manage while going on. See, I forgot Twitch has advertised book. Okay. Why is it not reading from the file? How do I make it read the file? I may have to look this up. I'll do that on my laptop. First, though, let's do a voltage measurement here because I want to see if this all is working correctly. Lady Ironborn, thank you for the gifted sub. I still need to adjust that to be longer. You know what? Let me set a reminder for that because I want to make that longer. It's going to mean redoing all of my animations, which is going to suck, but it'll be worth it. Tasks, longer, alerts. Okay. Save. Okay. See, at least for the time being, no more ads for you. Okay. What am I doing? Oh, yeah, we're going to test the stuff, the sense wires. So I'm hoping maybe having those will make this work a lot easier. So let me grab, I put the LED back. Why did I do that? And I put the breadboard back. I put everything back. I was all smart and I cleaned up. Jeez. Lesson learned, be messy. See, let's grab a cooler LED this time. And the breadboard, which I think I can actually use the breadboard for reforming small caps because it's not that much power. Let's see, from what I can tell, it's checking read from file and putting the path below the checkboxes, below them. Read from file. Oh, I'm an idiot. Okay, hold on. This, volts, boom. Okay, so that's what I put in there. All right, now let me try something. I want to go over to the laptop. We're gonna go over to, oh, thanks for disconnecting keyboard. You're so good at this. Come on. There we go. Okay. I'm going to vim volts.txt. Okay, we're going to change this to 80 dot. Oh, why did it insert 80.86? Okay. Right, quit, and then I want to SCP volts to the other computer 192.168.12.216. Now we go to media. A068. Boom. And oh, hold on. This overlay does not have the thing. Let's do this. All right, I'm gonna hit it. Yes. Bingo. Yeah. So from the laptop, I was able to change it. So that means is that I can have a separate like watched process that will automatically update stuff as I do measurements. So I can have it print to the display there from the laptop, just doing Linuxy type stuff. So that'll work out really well. I don't know that we'll get to that in this stream, but eventually I will have something set up for that. So that's the plan. Unfortunately, I don't think I can have this thing just set up to like automatically spit out data every time it takes a measurement. You have to actively read from it, which is going to make it a slight pain, but I think it'll be worth it. Or maybe that's the fetch command. I'll have to look back at the manual to see, because if the fetch command will just bring back any data that is available, maybe that would work. Let me look at that real quick here. I guess I can do this. So 3441A manual. Let's take a look at this. Measure. Where's the fetch command? I was looking at all this right here. So I think because they're sys commands, system commands. It might be at the back. Weird calculate commands, triggering. So that's close. Measure, read. No. What is fetch? Where is that? Fetch. Transfer readings stored in multimeter's internal memory by the initiate command to the multimeter's output buffer when you can read them into your bus controller. Okay, so if I just run the fetch command, it might actually pull the data. So can I scroll into this? Or maybe I can click. Oh yeah, that's right. That does not do what I would think it would do. Up and then over and then up, fetch. Okay, and zoom out one more time. Okay, so there's the fetch command. So it's anything that it's read, I think it will then do. So I might be able to have a program that just does fetch commands from it. So I can be working on it and then the readings are automatically put onto there. So see. Have a Python script that always runs on the laptop and gets the last measurement and sends it to the text on a constant loop. Yeah, that's what I'm saying. But the thing is I can't have it do other commands. Like I can't have it configure it for volts and whatever the thing or whatever it's set for. Like, so the thing about fetch is that I believe it will just take whatever is currently on, if I go back to this, whatever is currently being displayed here will be set to the buffer and then can be read back. So it'll do whatever. And it might even be instantaneous. We can try making a small program here that'll do the fetch. So we'll see. Okay, catching back up here. Overlay, not in this. Yeah, I did fix that. To be honest, spies using Google stuff. See, the trick is what the output from the GFib interface ends up being and how it handles it. Might just append the text into the file, which may create So I think I'm going to get this nailed down, Taters game. I think I'll be able to do this the way I want. Let's see. Okay. So let's... first off, I want to check the accurate... or the LED. You know what? I should just grab the same exact LED I was using before because we characterized that one. I want to check what this does for power and what it reads on there. And that, you know what? Let's do this. Because this is really hard to see. Maybe we'll just... maybe I'll do a thing here. Let's do this real quick. I'm going to make a simple program that I think will do exactly what you guys want. So let's try. Vim, no, I'm going to CP example to read amps.py. Okay, Vim read amps.py. Okay, so we're going to set the device address to 12. And just a number on screen will be fine. The main program can change settings in between. Yes, that's yeah. I'm going to try and do that right now. So let's see. That's all good. We're not going to do that. We're not going to do that. Okay, PSU example. I don't want any of that. I want, if I go back here, I need to do V or I out. That's what I want. So we're going to do write I out question mark, and then we will do a read back. I don't know what the format's going to be, so that'll be interesting to see. But let's close that, or comment, and I'm going to yank that, put it there, and we'll comment this. Boom. Okay, now I think if I just run this, read amps, okay, ch mod plus x, read amps, okay, read amps, boom. Well, that took a while. It switched to remote, it tried to do a thing. I don't think it's happy. Let's see, Oh, man. Okay, gpib error, write failed, reader write was aborted, possibly due to a timeout. Okay. What went wrong? Should be I out, question mark, returns the amperage. Okay. Device write, device read. Maybe I should get rid of the float? Is there something else? Is there like a read data command? Does something put it in the buffer and then there's something else you have to do? Let's check the manual here real quick. I uploaded the manual to archive.org, by the way. It wasn't up there before, so now it is. Let's get a look at the commands. Let's go single page because it's small. And make it... Oh, you can just control scroll on the PDF viewer. I did not realize that. Well, that makes life a little easier. Okay. Hold on. Stray I on line 22. Oh, really? 22. Oh, man. Oops. Okay. Let's try that again. Perfect. That is what this is showing as well. All right. So now let's do read amps into volt.txt. That will clear it, okay. And then we will, and actually, hold on, I'm gonna do this. Read amps into volts, and boom. So this should read it and then send it. So let's do, actually I'll leave the laptop up, we'll switch to this. I'm gonna run the command And it'll take a moment. Perfect. It's off screen, but I will fix that. So let's say, actually, let me modify this. Can I have it right aligned? I cannot. Okay. I'll set it to word wrap, but that won't really help. I'll just, okay, I'll put it at the bottom, like right there. Or over, no, right there. See, okay, the answer is to enable chat log mode in the text box OBS. This will display however many lines of history you want. What? Taters Games, I'm missing the context of what you're talking about here. Chat log mode in the text box in OBS. This will display however many lines history you want. Chat log mode. I don't want it to display a history of things, if that's what you're talking about. I only want it to display the most current reading. That's what I'm trying to do here. So what I'm going to do is I'm actually going to wrap this whole thing, and I'm going to do watch. Boom. No, that didn't work. Why did it not work? Maybe, no. Let's do that. Why is that not working? Maybe not pretending it's a variable. Syntax, unexpected token. How do I watch? You know what? We'll just save that as a whole shell script. Why not? Vim, update, sh, whatever. Bin, bash, meh. chmod plus x, update, boom. Now watch, update, there we go. Now that should constantly send a new current reading every 2 seconds. So I will pop this in here, and then I will grab my jumper wires, script section. What are you talking about? Let me hide the laptop. That looks like that's updating. Let's see. Yes, turn on chat log mode and set lines of history to 1, then it will then only display the most recent reading. That is what it's doing right now, though. I'm not sure what you're trying to, what needs to be changed, Taters Game. Okay, so go with these. Do the thing I did yesterday. Connect them to the lugs. Oh, that's a thing. They're getting the banana jacks take up the hole in there. I didn't realize that. Ugh. Okay, so take those out, and then I'll plug them in. See, I was assuming that whatever is going to grab results from the interface would append its results to the text file instead of simply overwriting it. Oh, yeah, so what I did is there's 2 ways you can do logging in Bash with the pipes. Wouldn't constantly rewriting the file be wearing out the laptop SSD? It would. What I should do is I should make like a RAM disk and do that, but there's really, this is not an ideal solution at the moment, and I know that. I can optimize it later. This is just a quick and dirty one for right now. Because eventually this stuff's all actually going to be connected to whatever the streaming computer is, most likely, not necessarily the laptop. And then it'll be done differently entirely. So, okay, that's that. Set I set, oh, local. I set, oh, that's a problem. The instant it gets a reading, it disables the control panel. Huh. This is actually custom made. It is quite nice. It needs to have rubber feet added. I never got around to doing that. So I'm going to have to stop the script temporarily here. But then I'm not really going to be able to update it. So this is kind of, not great. But we'll figure it out. So local control, iSet. We'll set this to 0.01 amps, which would be 10 milliamps. VSet, 3 volts. Enter. Okay. Then we're going to put the LED on. Boom. Should be on. It might be because these are not connected, or did I get it backwards? No. Let's do this, and then I'm actually going to splay these out a bit. So, positive sense to there, negative sense to there. Why is it not working? One of these not connect correctly. That's weird. Okay. Boom. Boom. Give me a voltage reading. VSet, 3 volts. Okay, that's concerning. Control it from laptop. I don't really want to right now. Right now, I just want to see it work. So VSet 3, enter. Okay, 3 volts. Okay, iSet 0.1. Oh, not that. I don't want to nuke that LED. iSet 0.01. Enter. Okay, now that's correct. Plug these back in. No LED. It's not taking current. Is LED backwards? Am I forgetting how these work? No. What's the deal? Boom, boom. We tried connecting it straight to the banana jacks. That's not working either. Stripping OC protection. Over volt protection right there, it looks like maybe. Reset. Okay. Do out off, and then I will plug this all back in. Boom. Get the sense clips on the LED. Plus, minus, make sure they're not touching. Okay, output on. And no CV, reset. High set is 10 milliamps. What gives? This is super weird. Or dead LED, try with battery. I don't have one handy. This just worked yesterday, though. It doesn't look burnt. Really quick. Go back here and look at the connections. Okay, it doesn't light up when pressing the screw terminals in the back, so it's not that. Sense wires are properly plugged in. What replaced GPIB? USB, really. Because GPIB actually stuck around for quite a long time. These are 1987, this power supply. This thing is really recent. It's possibly 1996, I think, for this exact version that I have here. But you can still order this today with a GPIB port on it if you want. You do have to get it custom ordered. Yeah, button cells have high internal resistance. Well, okay, so here's the thing. I don't have a button cell. I don't have one that's charged nearby. I only have them that are dead. The only one that's charged, well, I guess I do have one that's charged. It's in this thing, the 46 PC, so I can grab that. That popped out easy enough. All right, boom. LED's good. So there you go. LED's not bad. There's something wonky going on with the power supply for some reason. So if I connect the LED straight to the banana jacks, positive, negative, come on, just jam in there. Well, if I do it this way, boom, reset, nothing. Why? That's so weird. Plug it into the DMM to read the voltage. I did, and it's working. Boom, boom, 3 volts. Thank you for the 10 bits, G5. Short to output, check it goes to 0. That's not a bad check. Boom. Yep, 0 at 10 milliamps. What? Wait a minute, that's at 9 milliamps. Yeah, that's right. And it says it's CC, so voltage limited. Boom. Boom. Wait a minute. It very, very briefly lights the LED and then doesn't. It goes into CC almost immediately. I set, that's 10 milliamps, right? Like, look at that. That's 10 milliamps. 0.01, that's 10. But then it instantly goes into CC. The instant I tap it. Okay, I set 0.02. So give it a little more gas. Okay, that's working. All right, we'll go with that. Weird. I don't know why 10 milliamps wasn't working. It was working fine yesterday at lower. Now it's not lighting on the breadboard. What? This is the most confusing thing. This should be simple. Why is it not? Wait a minute. OV, hold on. Reset. Okay, that's fine. Then, boom. That's good. Boom, boom. That's good. Plug it in. That's good. Okay. Let's sense correctly. Boom. And boom. And that should now be good. Okay. Weird. So weird. Real quick, if I do the laptop script, it'll update. Bingo, there we go. That's now running. Didn't we have a resistor in series yesterday? No, we did not. Bet what's happening is 3 volt. The LED will flow more current, so the power supply is dialing back the voltage. 3 volt is slightly high, yes. And it's now current limited at 20 milliamps, so that's fine. All right, here's what I want to do. I want to try adjusting the current with the LED connected and printing. So I'm going to can this, and then I'm going to run it in the background. So that should stay updating. And then I'm going to CP read amps as set dash amps. Why did it stop the program? Oh, it didn't. Weird. All right. Okay, vim set amps, and we will do. Actually, you can't see this. One moment. Let's go to this for a moment. So I'm gonna hide. Comment out that. Use this. Oh, is there a way of really quickly getting a parameter in Python? Dang it, I would like to have that. This is where bash is kind of better, because just $1. You know, I'll just set it here. We'll just update the file, I guess. Okay, I'm gonna set this to 10 milliamps. Boom, that should all work. I don't know if this will actually work if it has an exclusive access to the interface. It may. Voltage drop, didn't we? Voltage now, it's enough to overcome diode drop. Looks like supply reduces the voltage limit to the current. Yeah, that's how it works. It'll current limit or voltage limit. A read or write of bytes has already been aborted, possibly due to timeout. I'm thinking it can't get exclusive access to this. Sys-argv. Yeah, it doesn't. It does have argv, but the problem is that you can't. It's not. I'm gonna have to look up exactly what I'm gonna have to copy paste in here. It's not immediately easy. Python arguments. Yeah, but I have to import sys as well, if I remember correctly. So I'm looking up Python stuff. Don't give me C code as a first example. Stupid tutorial. Paste. Then, yeah, sys argv 1. It is 1, not 0, because we don't care what the path is. 1. All right, there we go. Thank you for pointing me in that direction, though. So, you see, something like arg parse is exactly what I don't want. Okay, so I'm gonna have to kill that. Let's go back to the camera. Let's go back to the camera. And I'm going to do set amps 0.01. It's still not working, actually. That's weird. Scan FG. There's nothing running in the background. We've stopped updating the display. Local iset 0.015, just to make sure it's all good. It's working correctly. Okay. Check set amps. Iset. No. Oh, that's not gonna. It's not gonna like that. We're not. No. Okay. Now it'll probably work. Boom. Yeah, that worked. Okay. So now, let's see. I will do. This set amps, and then the power level that I want to set it to. So I'm going to try 15 again, and sleep 1, so it has a chance to update, and then we'll read back the current. Okay, so this is the command I'm about to run there at the bottom. Now let's see if it sends it and reads out the data, and boom, it did. Okay, so now we're setting the data and reading it back. So I'm gonna put the camera here so you can see the LED change intensity more easily. Let's see, arguing with your arguments. Hello, Cody. Okay, so now let's set this to 5 milliamps because I want to see if the sense wires make a difference. 0.75. That is the minimum that we seem to be able to hit, is just 0.75 no matter what. It is, man. That's annoying, but oh well. So I could try setting it for lower in case that's like a weird rounding error. Let's set it to 2 milliamps. 2. Yeah, no change. So, all right. Let's see. Never knew he streamed before. I've been watching him and Draga for years. The reason I now have 5 PS2s, that's a lot of PS2s. Yeah, the streaming is fairly new. So, okay, we can't do too much to fix the current limiting, minimum, that is, but we can set it to 10, which is what we need for capacitors. So set it to 10, wait for it to update, that's perfect. And then, yeah, that'll work out well. I can also loop the update code, and then we can see it change little by little. Maybe, is it not actually going to change? The voltage is changing, but it's locked pretty steady on the current. So that's good. Might be the regulation limit of the PSU. Yeah, I was trying to figure that out by looking at the datasheet stuff last night, and I couldn't find a good reference on that in there. So, yeah, I don't know what the bottom floor is going to be. If we really wanted to be fancy, we should use a current limiting resistor and do it that way. The initial way I was going to do all of this was going to involve one of those, but I don't want to do the math. I don't like that part of it. So, and then the other thing is that you need to change out the resistor for different values, so it's a pain. So we're just going to not bother with it. Plus, it'll limit my voltage top, and some of the capacitors I need to do are 40 volts, and this is only a 50 volt power supply, so going or reducing that down is not going to be a good idea. So, because the idea is I'm going to be able to just take a capacitor out, plug it into here, and do stuff. So that's what I want. But all right, that is that. So there is something I wanted to do. Let me grab, I don't want to use these. Guess I'm going to use my other clip ones. So I want to see what the resistance, or we taught Sam to do math. Hold on, math is hard. What's the model? See, might be the regulation. This is a 6633 by HP. If you go to here, you can find the GitHub repository that links to the manual that I put up on archive.org. So yeah, on that note, let me do a git commit dash am add test scripts git push. Oh, hold on, git add period boom, and git push. Okay, now that also contains the little files that I was just working on there. See, oh, has a range. Wow. Okay, reading. Okay, so my fail there, I guess. J-Man, while you're there, can you see what the 6632's floor is for current? It's on page 12. Actually, I guess I can just look at it. Okay. $66.32 is $15. Ouch. No, 66. 20 milliamps. Yeah, 20 milliamps is no good. So we're only gonna be able to make this work because I have both of these. Okay. So I have the 32 as well, but that one's not gonna be suitable for this with that really big step. Oh, it's page 1-2. Ah, okay. Perfect. Okay, so yeah, all right. So unfortunately, I don't have the 6634. That would honestly be way better. I might start an eBay search for one of those just in case. You know, while I'm at it, let me look at the 6624 because I also have one of those. HP 6624 in case that actually is better for this. Okay. Oh my gosh, no. Absolutely not. Looking at specification sheet for it, where resolution, average programming resolution for current, 10 milliamps is as good as it gets on the 40 watt output of that thing. Yeah, no, pass. So the minimum step it can make is the maximum that we're going to be using here. So that's a no-go. I think we're actually gonna, man, I really hate this. I think we're gonna have to use a current limiting resistor. I really do. Yeah, so let me do this. Let me go back. I need to find my post about it here. So this is the setup that I would be using with a resistor. So max VDC times that would give me current limiting, and I would have to actually measure the current. That might work. So let's say this is 2 volts for the LED. We would need a 200 or 2K resistor. So let's get that. Go with, I got 2, actually I have it. Let's go 220. Or, you know, yeah, 220. Set the voltage at 2.2. I want to bring this back to local control as well. Because I think with this angle, you guys, nah, not quite. You can't really see it. Well, whatever. Okay, local control. I will. Oh. That's terrifying. Since the sense leads are internally connected, the power can go through those too. How do you disconnect the internal sense leads? University lab, we had special boxes for all the low currents we needed. All the normal gear couldn't supply it. Yeah. See, that's the thing. You do need extremely low current. So I'm going to put this high side. Okay, but this isn't going to work if it's bleeding through. You don't disconnect remote sense. Yeah, so... Yeah. Sense before at the current limiting resistor. Okay. There. So now we're down to 4.6 milliamps. So we've halved the amount. And we're at 3 volts. So that's the thing. Now the voltage rating gets wonky. So what I'm going to have to do, I have to take probes here. And now I have to measure the voltage where I actually want to know what it is. So coming from, go to ground to the LED, although this actually is going to tell me the voltage drop, isn't it? No, that's right, 2 volts, perfect. So there we go. Now we can see that's our ideal voltage, the correct one that we want. Yeah, its diode should be dropping about 1.5, probably. So, okay. Yeah, that math checks out. So is that halving the current? Is that what we're doing? We can halve the current by doing that. So I'm going to try, see, I'm going to I set to 5 milliamps. So let's see if that works. I set 0.005, enter, see if it goes higher. Probably not, because it's half steps. So let's try 0, or I set 0.006, enter. It might be able to do that? No. Okay, so it's set to its minimum, and it can't regulate it any higher. So if I set it to 9, then it might go to like 6. So I set 0.009. No? Oh, because we're voltage limited. Okay, so V set 3.5. I don't like this, but all right, there we go. We're still limited. Okay, now I'm going to set it to 5. I set 0.05. That's 50 milliamps, no. I set 0.005. Enter. Why is it overshooting? Zoom. Oh, yeah, yeah. It's in CV mode, so whatever you said, it will not take effect. It'll switch between them. Yes, not enough voltage, push the current higher. Yeah. So the camera is just going to lose me because I'm kind of behind stuff here, I think. So I set 0.005. Ooh, that might be a problem. No matter what, it won't let me set it lower than 7.8. So even with this, it can regulate lower than 7, or it can be lower. This won't work though because I can't set it to anything lower. Huh. Use DMM to measure cap voltage. That's what I'm doing. I am measuring the LED voltage with the multimeter up there. So, and calculate current by voltage drop over the resistor and control changing supply voltage. Yeah, the thing is, I'm just going to say it this way, all right? I have no problem doing all that math when I can sit down and plan it out. It is not fun to do that kind of stuff on stream. So that's why I'm not really keen on doing that at the moment, because I'm going to have to sit down and I'm going to have to plan it out and research exactly what I want to use, because I don't know all the formulas offhand. So we're not going to do that right now. We'll just go ahead. I will plan to do that in the future, but I'm going to have to do the research off stream, and then we'll update this to do that. But for right now, I know the math can be done by Python, the actual calculations, but to build the formulas, I'm going to have to do the research. I don't know everything that I need to do that right now. That's the problem. It is shockingly hard to do technical stuff on stream like that where you're going to need to do formulas like that. So for right now, we'll just go ahead and continue, and we'll work on setting. We'll work within the limit that we have between 8 and 10 milliamps. So, Ohm's law be a harsh mistress. Yeah, it's more that you have to figure out the correct application for exactly what you want and do all that. I'm not prepared to do that right now is what it is. So, okay. Let's work on our basic logic for the code first. See, so VSET would be the voltage output of the multimeter. So, okay, that's the other thing. So your iSet, you're not getting, or hold on. Okay, let's do this. All right. All right, so here's the thing. If we want our capacitor to have, let's just go 2 volts across it. So this power supply, VSET is power supply, yes. So we have the power supply, or the cap, we want to be at 2 volts. Okay. The I-lim is the resistor that we're using. We're using a 220 ohm resistor. The iSet is what we want to set the power supply to. So we're calculating that. Set is what we currently, see, hold on here, VSET. So again, all right. So we're setting the power supply to, let's say 3.5, all right? 3.5 equals, or minus, okay, so we're gonna get, that was 5.5, that's not what I wanted, but whatever. So what I really want is I want to be able to specify the current. Yeah, I don't really care what, no, I don't know that you're actually understanding what I want. I have 2 levers I can pull, okay? I can pull the volts and I can pull the amps. So I want to know, or I want to limit the amps to 5 volts, so, or 5 milliamps, let's say, okay? So I'm going to set the output to 5 milliamps, all right? So I know what iSet is going to be. If I want to find VSET for a given current, yes, that's the thing. So for V over IR, but that's not accounting for the voltage drop on the resistor unless it's V minus. So yeah, see, this is Shout 76, kind of why I didn't really want to do it on stream. So let's say the voltage is going to change because we're going to be current limiting. So the voltage will slowly rise. But we have to max out the voltage at a specific point so that we don't go over. And the power supply is going to be reading a higher voltage than we can set, than we can do. I find it helpful to finish one thought before beginning the next. Yeah, definitely be easier if you had a finer control current source. Yeah, I just don't think we're gonna get that. That's the problem. So I think the only way we could realistically have a finer control current source is if I built something using a digipot that goes in between the power supply so it could set its maximum voltage. So Brian, okay, so here's the thing. The actual numbers are completely meaningless to me. I don't care about the numbers. It's not, I mean, I appreciate you calculating the number here. It is the formula so that I can write the code for the different things. Because like, let's say I want to reform one of these caps right here. These are, well, those are 200 volts. I'm not reforming those. That's okay, let's just pretend we're not looking at those. I have a 1000 UF 16 volt capacitor here, okay? So I need to be able to plug into my Python code 16 volts as a variable. And then it needs to calculate with the current limiting resistor that I'm probably gonna have to change. So that one I might use a 160 ohm resistor, or I don't think that's actually a E12 or E6 value. So the closest to 160 actually might be 220, unfortunately. So I'll be using a 220 ohm resistor, probably. So what about Dave Jones' microcurrent? Isn't that just for measuring really small amount of current? Okay. Let's try that, Hellencroft. Okay. So yeah, so the measuring the current is one thing. We have to be able to control the current. So a digipot, just for reference, is a digital potentiometer that you can program over like I2C SPI or something. And it's just a potentiometer that allows you to split the voltage or current if you want. And what I would do is I would use shunts like the microcurrent with that to do the measurement. And then I would modify the amount of current coming out of the digipot, based on the reading of something like a microcurrent. See, I thought it was supply 2. I don't think it's supply. Okay, let me try Hellencroft's thing here. Okay, so we have V cap. Okay, so let's say we have a 16 volt cap. 16 volt cap, okay. Plus I set, so we're gonna have 5 milliamps is what we're trying to hit, times 160, because we're at a 16 volt cap. Okay, and then this would be the voltage limit that we're gonna hit. I messed that up. So we would set it to 816 volts. VCAP is the VCAP plus, okay, VCAP is the current voltage measured by the DMM, yes. So that's the other thing, 0.05, oh yeah, I'm an idiot, sorry, 0.005. Okay, so it'd be 16.8 volts. I kind of want to... Let's do this. Let's make an LED array that can work in higher voltages and consume a more variable amount of current, okay? How would one calculate it the caveman way? Python code seldomly plays nice with my system. A calculator? I mean, it is fairly basic stuff. It's just trying to get it set right. Oh man, I forgot I made these. These are like really nice high CRI Cree LEDs that are on little things. Okay, we're gonna use a bunch of red LEDs. All right, we're gonna put them in series. I forgot what color this is. Let's just find out real quick. Light. VSET 2.5 volts. I set 0.01. Okay. This is not working. What? Oh, because it's remote local control. No, that should have been working. What gives? Why is that not turning on? Should I try it with these? Why is that not working? Over voltage, reset. Okay. Boom. Okay, these are the red ones. Okay, we're going to use red ones. All right. Okay, so I'm going to put these in series so that we increase the voltage. I'm going to put 5 of them in series so we can run... No. See, I want to reach 20 volts. We're going to run them at 2.5 volts because that works. So 8, because 2 of them together would be 5. 5 times 4 would be 20. Okay, so we're going to have to put 8 of them in series. These are 2 LEDs per package. So I can actually do this, combine the 2 legs there. And put these together like that. Make power. Do, nope, backwards. Boom, that's not working. Why is it not working? Overvolt protect again? What gives? Oh, because 2.5 volts isn't enough to turn on 2 of them. VSET 5. That's backwards. That's not playing nice. Overvolt protect. Okay. There we go. So that'll work. Okay, so that's 5. Then I just need to make 2, 10. Yeah, so 8 of them. One. 2. Three. Very slow. Let's see. The whole point is VSET will slightly exceed VCAP, yes, so that we can reduce the current. So what I'm doing here, the intention of this, is to allow me to gain a finer grain control. This will actually draw a lot more current now that I'm thinking about it. But this should, I believe, provide us a slight resistive load because we're going to, yeah, VCAP can never go above the rated cap voltage, yes. I'm not wrong, and this is going to be a correct test, it's a valid test, right? I'm not pretty sure it is here. So there's 4. That should be 10 volts, all right? So, what is it? VSET 10, enter. Is that backwards? Or is it overvolt? No. But it all connected correctly. Seems like it. Maybe one of them was burnt out or something. Okay, 5. Oh, that's 10. Actually, this should be 20. Oh, it is just 4. I'm an idiot. VSET 20. On VSET 2 0. Boom. ISET is 10 milliamps. I'm going to leave that. Okay. Okay, I'm going to give it. Oh, it's overvolt. There we go. Okay, so we're at 20 volts. Boom, boom, and then we can do this to that, and they'll fire up. So, if I ground this side, okay, I want to be able to run 5 milliamps through here. So, if I do this and we follow the formula, 5 milliamps, I'm going to use a 220 ohm resistor. I set this to that, so I should get 5 milliamps if I set the voltage to 21.1. This will measure the current correctly, so 21.1. This is 220 ohm. I am current limiting. You do this. Measure. All right, so here's where we're at. We are getting, and stupid cables all over it in the way. We're set to 20 volt cap, and can't see any of the power supply settings. That's perfect. Okay. Programs two functions: one, calculate the VSET, get one current, and stop the VCAP, reach rated voltage cap. Yes. Okay. So, really quick, let's bring this back here. I am current limiting at 10 milliamps. I want it to be 5. So I'm going to. Well, I can't. If I set it to 15, 0.015, I set 0.005. Drops down to that. So I'm not getting the results I'm expecting here. Hello, Chloe. Finally starting the reforming stuff. I'm getting close. Right now we're trying to determine if we can calculate a resistor, a current limiting resistor to put into this, because this is complicated and we're kind of burning a little bit of time here on this. So yeah, the actual engineering side of this type of stuff takes me longer because I'm not directly trained in this, so I have to do more research as I go along to have a better understanding of what I'm trying to achieve. So I was kind of trying to go based off of what people were recommending in chat to go with for this. So what I'm trying to do right now is limit a bank of LEDs to 5 milliamps of current as a test with this power supply. And I've added a current limiting resistor in series with them. So the power supply is set to a maximum voltage of 20 volts, but it's not reaching that because it's current limiting below that. So I guess I could try setting VSET to, let's try 11. Boom. LEDs turn off, which makes sense. Move these in a little more here. Maybe you can see some, but then you can't really see the current. That'll work. So if I do VSET 13, enter, they weakly turn on. Okay. So this is what, we're now drawing 1 milliamp, which is kind of awesome because that's the kind of thing we want. So what we're trying to do is figure out the relation between the current draw and the actual voltage. So there's another thing here, is that you can see we're setting 13 volts on the power supply. We're only measuring 2.8 across the LEDs. That's what the top meter is measuring. So you're pulling an Ozzy Osbourne shot in the dark a little bit right now. I'm probably going to abandon this. See, now we use the formula on the laptop with the right resistor value. So we have to calculate the resistor value. That's what we want to do. Because we want 20 volts at 5 milliamps. So, okay, now we use a formula on the laptop. What resistor do we have? A 220 ohm resistor in there right now. What I'm trying to do is 20 volts at 5 milliamps. VCAP equal 12.9. So that's where we're at right now. Yes, the multimeter is measuring the voltage across the capacitor, which is currently LEDs, but it is functionally the same right now. For those who are maybe not totally familiar with the process I'm trying to achieve and everything, I'm using LEDs right now. I've also not explained this too well. I'm using LEDs right now to to try and calculate the resistance and set value of the power supply to get a particular voltage and current. And I'm not using capacitors because capacitors will charge and then they won't accept any more current. The LEDs use the current up to emit light and generate heat. So they make for a better test subject right now. So that's what I'm doing. Okay, so 12.9 minus 0.05 and 220 ohm. So 14. So if we set it to 14 volts, you're saying we'll get 5 milliamps. So VSET 14, enter. We get 4.0, but that could just be a rounding error on its part. Some pseudocode. Okay, I want to take a look at that. Okay, set PC voltage. All right. Okay, so let me try. I'm curious. 14 or VSET 14.5. Yeah. Okay. So I think it was a rounding error because that's now 5.8 milliamps or milliamps. VSET 14.2. Yeah. Okay. So so is the VCAP value arbitrary? So if I want VCAP to be 20, it'll be 21.1, but then it won't be 5 milliamps. So yeah, VSET 21.1, and now we're at 30. We're at current limited because I have iSet. I'm gonna set that to 0.00, not 001, not 1. iSet 0.01, enter. Okay. VCAP changes during reforming. Yes. Yeah, because the voltage will raise as it pulls in more current, yes. So that needs to be constantly pulled, I guess. So looking at your pseudocode real quick, Opossum. So you're looking if V supply is greater than V max. We need it to be V cap is greater than V max because the supply is going to have to be greater than V cap or than the max voltage because we get a drop going into V cap. So I might check against that. If V supply minus V cap is greater than delta, voltage to maintain across the resistor. Yeah, no, it's fine. I pseudocode doing. I'm just streaming and all that kind of stuff. I understand. So I'm just trying to figure out what will make the most sense here. So, so our V cap is effectively 13.4. So if our V cap is 13.4 and we want it to be 5 milliohms. Okay, I'm starting to understand this now. Because that looks right again. Green Source, thank you for the gifted sub. I really appreciate that. We're not doing the most exciting stuff right now. So, I really appreciate that. Basic feedback loop that reads VCAP and calculates VSET given fixed current and resistor value. Yes. So, yeah. So I'm curious then. Let me try this. I'm gonna run the math. I want to set it to 2 milliamps. So we're currently at 13.4. I want to set it to 2. So 13.84. VSET 13.84. Boom. We're at 4. We're at 13.1. Let's update the loop. So 13.5 VSET. 13.5. Enter. Okay. Think of it 2 pieces, voltage across the cap, the voltage across the shunt. See, did he show a circuit diagram before? I kind of did. I can go back to that and show that here. This is not really up to date though, actually. I don't really want to show this. Well, actually, okay, we can look at this. So ignore the 34401 DMM here, because the power supply I'm using actually does what that is measuring right now. So the analog voltmeter is effectively the voltmeter that I'm using up on top, okay? Now, the difference between that schematic and what I'm actually doing here is that everything is connected to a computer and is readable by the computer now. So what I'm trying to do is automate the reforming of the capacitor, which needs a set amount of current over a period of time. So we're looking at a feedback loop that effectively there uses the analog voltmeter to measure what the current voltage is, and from there calculate what voltage we need to set on the power supply to achieve a certain amount of current. So that's what we're doing. So, all right. Let me try something here. So if I have 5 milliamps, let's say I have a 40 volt capacitor, all right? And it's at 40 volts. I'm using a 220 ohm resistor. Okay. What if it's a 0 ohm resistor? Just 40 volts. That makes sense. Okay. What if it's a 2200 ohm resistor? Then it needs to be 51 volts. Okay. So the lower the resistor value, the better. So we don't actually measure the current. We calculate it from the difference between the 2 voltages on both sides. Yes. Yeah. I will probably add some kind of panic check where if it will measure the current, and then if the current is higher, then it should be back off the voltage no matter what. So we'll have to have the program start from a state of refresh everything in there, because at the end it might do that. Close Hitch wants me to change the keyboard. Okay, so we have 2 options here. I'm actually going to be a little disappointed by this, but all right. We can either go back to the Model M, because here's the thing, I was going to use a PS2 keyboard today, and the thing is when I found my PC 104 splitter adapter, I was actually looking for a PS2 USB adapter, and I couldn't find it. So we have 2 options. We can go back to the Model M, or we can use a Razer Black Widow Ultimate, because I can't connect PS2 keyboards right now, it seems. So I have this right here. So I'm gonna go with this for now, but if you want me to switch over to the Model M, just let me know. But I will go with this for right now. This is a cherry green switch keyboard, which is actually interesting because this is a heavier switch than the Model M. And there are not a lot of keyboards like that. And that's part of why I have this keyboard and I like it. But yeah, so if this is not fun for you because it's not a vintage keyboard, just let me know and I will switch to the Model M. But those are the only 2 that I can apparently do right now. That and the Apple keyboard. But I'm also going to kind of put my foot down on, I need a keyboard that's really good because I'm doing ideally mostly programming right now. So, okay, let's go with this. Now I have the keyboard cable tangling on the power supply cables. Okay, there we go. All right. ESR assumed to be infinite. We're not worried about ESR right now. The assumption is, if we're reforming a capacitor, that it's not super bad, in that we're going to be just hopefully doing a refresh of it so that it doesn't blow up when we plug it in. So let's see, interesting deal. OPC sensors calculate speed based on milliamps. It's very odd. All right, I'm worried about as the cap charges, the resistance of the cap is going to change. Yes. So you need one of those rubber folding keyboards for hacker vibes. Oh gosh, no. No. The whole point of Change Keyboard is not to make me use miserable keyboards. It's to explore interesting keyboards that I have. So, okay, because generally I'm trying to get something done, so I don't want an impediment. See, and the LEDs are to stand in for the cap under test. Yeah, for right now, because if I have a cap in here, it will charge, and then it won't take on any more current. So that's why I'm using this right now. And I don't want to have to be constantly discharging the capacitor, because I eventually get full pretty quickly here. Why does that keep going into over voltage? Oh, because these keep touching. Oh, well that answers a question. So if I reset over voltage, these tap together and then it goes, okay, got it. So these sense things, should I be doing them here? Because this is now a little weird. Let's put them there. Reset, bingo, okay. Clear entry. Ooh, 1.7. Oh, that makes a big difference. So if I clip those on there, we get a different reading. That's interesting. So let's say our value right now is 13.0, and numpad doesn't work apparently. There we go. And we want to hit 2 milliohms. We should be at 13.44. So VSET 1.3, no. VSET 1.3 point, not clear entry. VSET 13.44, enter. And now it's lower. Why is it lower? Should I measure here? Now it's 10 milliamps. What? Why is it so high all of a sudden? Is that... Oh, I know why. That can't work. We can't use that. Okay. Okay, I understand why. All right. Resistor tolerance. Ooh, yeah. Okay, that's a thing. Okay. What are... I once had one of those rubber roller keyboards. Probably the worst thing I've ever typed on. Yeah, exactly. Yeah, even all that piggyback keyboards. Yeah. Get rid of those sense cables. Yeah, you know what? I can just unplug them. Check the actual resistor value. That's not a bad idea. Let's see what that is. $218. $219. I guess it's heating up. Curious if I put my fingers over it, will it actually heat up noticeably? No. Okay. That's pretty close though. So, all right, let's so we have this, and we can do positive, negative. Okay, I think I am... Oh yeah, let's go back to voltage. Okay, 218 is not 220. Yeah. So let's say 218 in the laptop code. Laptop says we should be... It's a 10 millivolt difference. Actually, 4 millivolt difference. So it won't... If we go back here, you can see it's not super significant at that low resistor value. The whole thing is a series connection, power supply, resistor, LED cap. Yeah. Diagram closer. Ignoring. Well, the schematic there, it's accurate. Everything is represented there. That is effectively what's being done. It's just that instead of the multimeter being used to measure the current, the power supply measures the current. And then the analog voltmeter is instead being used as the multimeter. So that's what's going on. Okay, I want to desolder one of the big caps on the ATX power supply board here that I have. And I want to try putting one of those on here, and then we will slowly raise up the voltage as we test, because that will change stuff. So, and then I'm probably going to try and super limit the current so that it takes as long as possible. So let me do that. What just happened? Why did that do... Oh, because VJ is not connected. Okay. So let me grab this. I'm going to have to cut this probably or something. I don't know. We'll see how it goes. Because one thing I want to be able to try here is, you know what? Let's do this. Let's do... Why is it millivolts? Auto range. Just do that. Range. How do I range? Auto. No, just turn it off and on. Whatever. So we set V set to 0. Helen Croft, I'm not sure what you're referencing with V set to 0. So what I want to do is I'm going to set output off. All right, and then I'm going to do a resistance test. Okay. So 22.6 and set that on. That makes sense. Off. Okay. So we have 20. We're doing 2 milliamps. Okay, hold on here. All right, one moment. VSET is to start a new cap. Yes, yes. Okay, one moment. What am I? I'm trying to think about what I want to do. If I'm going to do 20 volts times 0.002, I can go up to what? I'm not sure what you're referencing, emulate ATG. So right now what I'm trying to figure out is 20 volt divided by 5 milliamps, 4 kilo ohms. Wait, what? Oh, okay. So no, what I'm trying to do is I'm trying to figure out what would be a 1/4 watt resistor's max value for current at 20 volts. That's what I want to do. So I'm trying to figure out, I want to be at like half of that. I want to make sure that if I put a, like say, 1K ohm resistor, actually I'm just going to do it. What's the worst thing that happens? I blow up a 1K ohm resistor. Okay, so an alternative to what I'm doing here. I'm going to to take that out, leave all those over there. This resistor, now I mixed them up. This is 220. Boom, boom. I'm gonna grab one of these so I can stab into that. Oh, actually, no, I don't. Just need to do that. That should be okay. It's, we're output disabled. Okay, so output on. Yeah, that's fine. Okay. So we're current limited, that's okay. Here's what I want to do. This is a 1K ohm resistor, so this is a known value. What I want to do is, so, okay, we're measuring, you guys can't see anything, one moment. Cams, wait, why can't you see anything? Why is that? Did the camera die? The camera itself just died. There's now like weird output. You can see the HUD there. Dude, camera, GoPro. All right, guess who's getting turned off? And then back on. Hopefully. Says powering on. I don't necessarily believe it. Yeah, would be a TT stream without camera problems. Yeah, now I'm really, because I want to show you what I'm working on here. This is a slight problem. Please turn on camera. Getting close. Okay. GoPro needs a little direct replacement. That's what it needs, and that's what this is. Okay, back to this. All right, here's what I want to do. And we're back, yeah. So we're doing a measurement here so we can see that's our voltage drop across the resistor, okay? I'm now going to set output off, no voltage drop, and I'm gonna do a resistance measurement, and we get 7 ohms. Is that what I'm seeing? That's not right. So what's going weird? Is it that? No. If I unplug one of the banana jacks, there we go, K ohm. So this is what I was trying to figure out. Can I do resistance measurements in circuit of the capacitor? And it looks like not. That's a little disappointing, because I really wanted to be able to do that. Yeah, no? You cannot, no. Yeah. Well, it depended on how the output is disabled on here. If it's the actual output, if they just set it to 0, then probably not, because it's probably going to go through the internal MOSFETs or whatever. But if it like opened a relay, then it might have worked. That was what I was kind of hoping for, because I hear it click, and I didn't know what the clicking is doing. So I was hoping it would open a relay, because I really badly wanted it to be able to measure the resistance in circuit, because I want to log that somehow, and now that's going to be a real big pain. So, yay. Trying to think. I could have a relay that opens up once the voltage is set on the output, but then that won't necessarily always be the same. Real big fish. Yeah, that one's going to be more of a pain. I might just measure the resistance before and after reforming instead, because that I don't think is going to work. So, all right, let's pass on that for now. Why do we want to measure resistor in circuit if it never changes? No, I want to measure the resistance of the capacitor before and after reforming, because I believe the capacitors will become more resistive as they're reformed. This may go against conventional wisdom, but I want to find out. That's just why. I want to try and measure that just to see. I don't care about the tolerance, no. All right, we got people trying to look at this. Not the Wolfram thing here. Okay. I'm going to close that. There we go. Yeah, I think you pretty much got it there. So you guys are going about this a different way than I had initially planned to. I was going to automate the manual method. Caps become less of a resistor when you reform them. See, that's the thing. That's not what I've measured. Let me show you what I mean. The one capacitor I've reformed, I know it's a really big sample set. I did a before and after measurement. So I did I have two capacitors here. This is the one time I did reforming. I reformed one and then did not reform the other. The one that I reformed measured at 2 mega ohms, and the one that I did not reform measured at 22 kilo ohms. So that's what I want to see if there is any kind of correlation there. So it's probably like a curve you could find online that would show you common values over time reforming. See, there's not, yeah, that's a big difference, and that seems weird. So that's why I want to do a test. So I don't necessarily know it's an improvement, but I want to say that it is. But yeah, I don't find that there is a lot of information about reforming in general. So that's part of why I want to log resistance. And I would really like to be able to log resistance over time, but it doesn't seem like it's going to be practical. The whole leakage current thing is a parallel resistor that we want to get rid of by reforming. So my understanding of what we're achieving when we're reforming is that the dielectric that separates the anode and the cathode is thin in some places, and if you put too high of a voltage in there, it can jump the gap and short the capacitor, heat it up, and boom. So that's my understanding. What we're doing is we're rebuilding the thickness, which separates the anode and cathode with more material, and therefore increasing the resistance of the dielectric material. And I think that's what I measured there. But again, I know it goes against conventional wisdom from what I understand. So, yeah, you like my relay idea? See, I want to know this, but I don't know if it's practical to do. That might be a version 2 thing that we could do where we could separate the circuit, but I don't know. So, I could also just have, you measure leakage current. You measure leakage current in that tweet. So what I'm doing in the tweet is I have the multimeter directly plugged into the capacitor, and I'm measuring the resistance. Was this measurement taken on a multimeter or an LCR meter? This is just straight up multimeter 34401A, and it was and I let it dwell on there, so it wasn't just measuring the inrush current, because I know it does a measurement by applying current and measuring a voltage drop. So the real idea is a good one. Just controlling it would be tricky. Yeah, it would have to be done something externally. I was saying it would be cool if it could be set with the V out of the power supply. So when the power supply is off, the relay would open. But the power supply is going to be operating at voltages below most relays for the majority of the time, so it probably won't help. So, yeah, I understand that should be a leakage current measurement. So leakage current, the leakage current should go down as the capacitor's dielectric material increases, which means that it should measure as a higher resistance, as far as I'm aware. A resistor measurement is a current source and voltage reading, so the leakage current with extra math on top. Yes. But the leakage current is going down as the dielectric is thickened. So the resistance would be higher effectively. It's fine if what I'm doing is a leakage current test, but if I can do a leakage current test as a resistance test, then I think that works. Current sense loop, something or another on the op-amp, drive a MOSFET that will turn on your relay. Yeah, well, there's a lot of ways I could do it. Probably Starhawk would just be an Arduino connected with a serial port, and then the serial port just says, hey, turn off, and then it would turn it off. It's something that would be it would require it wouldn't require a ton of stuff. I mean, obviously I have some relays right here. I could just pop one of these into the breadboard. Just turn it on for like 10 milliseconds, take the quickest resistant measurement that you can. The relay. Yeah, well that's the thing, is it could be pretty quick. We calculate the reforming current, we know the cap voltage, so we can calculate the cap resistance. Reforming current, we know the cap voltage, so we can calculate the cap resistance. Yeah, that's straight up V over IR, isn't it? Hold on. Let's do this. We are currently powering... boop. We are currently powering a 1K ohm resistor, all right? We are doing 1.3 milliamps negative, I guess? Out. Okay, okay. We're doing 13.4, 9.3 milliamps once I stop. Ooh, that's interesting. Oh, actually, I would know what the resistance is, measurement power, because it says what it is. Okay. So we're 9.7 volts. This should be pretty simple. V over IR. So if I just divide voltage by current, I should get the correct result here. So it is 9.7 volts, 7.6, sure, divided by 0.009393 milliamps. Boom. Okay. Yeah, we can do that. I don't see any reason we can't do that. I like that plan a lot, actually. We're just using two separate instruments to basically do the exact same thing. I don't see a problem with this at all. I'm actually really curious now. I'm going to disconnect this from the circuit. I'm going to do my measurement. So the 34418 says that is a 988 milliamp resistor, or not milliamp, 988 ohm resistor. So we just need the two voltages, know the resistor, and we can calculate everything we want. Yeah. Okay. I might do that calculation, have that be part of the logging then, because I'm really curious to see how that changes over time, and then correlates to actual resistance measurements before and after. Yeah, okay. Let's get a cap off of that circuit board, because I want something to play with that's going to be more representative of what we're doing. Okay. Circuit board, give me your caps. Oh man, this thing sucks. Okay, get all this out of here. Boom. Soldering iron. Someday I need to buy a desoldering gun. Solder pult. And then I'm just gonna yoink. Let me grab the trash can so I can put the solder in there. Just gonna yoink off the two big caps. see. Come on, let go. There we are. All right. Think I already got the big boy tip on there. Yeah, from when I was doing definitely things you should be doing with a soldering iron with that 3D printer material. Get in there, come on. Oh man, that one I can nearly... Yeah, okay, I broke that one loose. Man, who needs a desoldering pump? But the alternatives, you have another method to control the relay. Yeah. So I would do a relay connected to an Arduino, most likely. The fun, make it overcomplicated person in me wants it to be an Arduino with like a GPIB interface. So I can have it all on the GPIB bus and write it in the same way in the same program, but that's such ludicrous overkill. I was actually talking with someone, they told me about HP has a general purpose I/O device that communicates over, it's actually like a switch matrix that communicates over GPIB that I could use to route stuff. That would be hilarious to get. Again, complete and utter overkill though. Okay, so there's those. We have some test subjects. I am going to call it at this point. What? Shelby Picard facepalm? What do you mean? Have an extra 34401? I wish. I really wish. I very badly wish I had 2 of them, but no. And they've gone up so much in price over the last year. It's absolutely ridiculous for such an old meter, but no, I don't. And I don't think it's going to happen anytime soon. About the Arduino plus GPIB. Oh yeah, for sure. Definitely. Not smart, but I would want to do it. Okay, I want to measure resistance of these caps real quick. Get a baseline. Let's also Sharpie them 1 and 2. I'm gonna go ahead and turn the direct light off here. We got enough room light. Okay. 1 and 2. Okay. I don't think there's any reason to involve an ESR meter in any of this. Because we're not going to be changing the capacitance. We're likely going to change the ESR. Well, potentially. But that doesn't really matter. So I'm going to try and do this as quickly as I can, because this will actually reform the cap, because the power is so low. So I'm going to try and get this. Actually, let me bring up a document here so I can have somewhere to document this too. Isn't this? There isn't, because you want to measure the dielectric, you said. Yes, yeah. I can't think of a reason to involve an ESR meter. I was going to grab it because I'm just so used to, pull off cap, put on ESR meter, but there's no reason to. Next, tell me what to put. Yeah. Okay. Control D. Actually, a Pi 4 could make sense to use for this. If I get this so well sorted to the point where it's like, oh, I'm just going to throw some caps on there while I'm at the office, it would make sense to have a Pi 4 run it on like automation. I just type in a keyboard over, or type in the voltage over SSH and then hit go, and then it just like runs somewhere else in the office rather than tying up my laptop. So no, it would make sense to use a Raspberry Pi. This is not very complicated. The Raspberry Pi could control the GPIB adapter is what I'm saying. So anyway, vim cap log dash 01 dot txt. Okay. So preforming 1. Okay, so this is cap 1. Positive side. I'm just going to tap the negative side. Actually, it does have to stay on there enough to charge it and then settle. Okay, 0.28. So 208,000 ohms, 280K. 280K ohm. Okay. 2. And this is interesting, actually. ESR equivalent series resistance, yeah. Watch this number on the multimeter increase after I connect the capacitor, because it's going to start reforming it and the resistance will start going up. Boom. So 250, I'm gonna pull it at 260. Well, it's sort of stable. Nope, there we go. 260, okay. It's 260K. So those are actually, I don't think those are doing too bad. They're not super ancient. Those capacitors that I showed you the pictures of were from the terminal. So from the Data General terminal. So they're good and old caps. These are probably not that old. If that's a date code, then that's 2010? No way. There's no way that power supply was that new. There aren't enough chips on here for me to get a good date code. Although, is that a date code on that transformer? 1007? 0950 on that one? Oh my gosh, is this thing from 2010? Weird, okay. Huh. Those are some really hollow sounding capacitors. They have very little weight as well. Okay, so these are 200 volt caps. We're not gonna get anywhere close to their voltage rating with this today. So that's not gonna happen, but we can get somewhere. I think it's gonna be the best way about this. I need to clip these onto that stuff, and these are going to be the best way to go about this. These are clips. See, sweep, we get them the whole response. I guess it's just overkill. Hold on here. Okay, while I'm summoning, saying them needles overcomplicated. I've got an HP VIA-based thin client running some sort of Linux console abusing the parallel port for GPIO. I've tried to do parallel port GPIO stuff. You'd really need an actual parallel port, and that's kind of difficult to get on newer systems or USB ones. Let's see. Oh, this must be... Okay. So if I want to connect these, that's actually going to be slightly a pain. Somewhere back here should have clips that just end in solid core wire, I think. Where'd those go? Or have they all wandered off? Trying to avoid making a set of clips here, but I think I'm gonna have to. Forget why I made these loops. Is that for clipping? For measuring? Oh, I put these on. I used this for soldering to something to get power supply measurements by clipping onto it, or oscilloscope measurements. It was oscilloscope measurements of the video signal on the AT&T 6300. Okay, that was it. Just trying to figure out the best way of connecting the cap. I think I'm gonna have to make clips that hang off of the breadboard for this. Yeah. Gonna have to be. Okay. Grab a short, I'm gonna make it a medium length of wire here. Some LCR meters have selectable frequency options. Usually they're fixed. My DE, 5,000, I think it is. This has adjustable frequency options. So, as it turns on, you can see there's all of the frequency options up top. So, it's fixed to be very limited. Yeah. Caps are rated at different frequencies, which is part of what really sucks when you measure just like random caps, because you have to know what frequencies to measure them at. You can kind of guess it based on the type, but you do really need to know. Okay, let me do this. I'm gonna make this. Okay, well this is already cut. Let's go with that. This is a little long. And it's low power. Nah, this is... Low capacitance need, high frequency, high capacitance need, low frequency, yeah. I think I have everything I need to make pretty much any cable I could want here. So that's nice. I'm just gonna make one that plugs into the breadboard and has clips coming out of it for right now, just because I think that'll be useful for this. I swear I had something like this. I just don't know where it is. I had a feeling I was going to end up making this cable at some point today. I was just trying to avoid doing it. Okay, that's well attached. That one's well attached. All right. All right, so the voltmeter will need to be connected to these, so this can actually piggyback through here. I'm gonna have this go through this. This will connect to the breadboard between the high side connected to the resistor and the low side connected to the, well, ground. Okay. So this is kind of the setup that I will be using here. So there's the, that's a 1K. I don't think we want a 1K. I think we want lower. I'm gonna go back to the 2K, or 220. 220 ohm, yeah, resistor there on the high side. And then, don't want this to be 13 volts. VSET, let's go with 3 volts right now. Enter. Senses are plugged in over there. Minus, okay. So, I'm about to connect a cap to power. iSet, we're gonna limit that to, actually limiting the power supply to 12 or 10 milliamps is totally fine. So, okay, let's do a calculation. Laptop. What all happened up there? Good grief. I just did a, okay, quit. Right, okay. This is cap 1. And, trying to decide if I want to do the programming step here or something else. It has to have a feedback loop. The voltage will drop over time if it doesn't, and that's fine. What's this solder blob on the side of this thing? Weird. That's okay. All right. Let me do code real quick. Let's do a little bit of code. I think that's a better next step. We're ready hardware-wise. We've got that sorted. Let's do some code. Okay. Let's make something new. Vim, I guess, reform. .py. Okay. I'm gonna open this as a split. This is a little brutal text size. Okay. Import. All that. Volt underscore max. I'm setting this very conservative here first. What's the actual description of the process here to increase the cap to its maximum rated voltage slowly? Actually, Viper 7, I've detailed exactly the theory in the GitHub repository that I'm currently working in. So if Nightbot will actually pay attention here. Come on. Work. There we go. You can click that and then go to the repository, which is somewhere here. Nope. There. You can go through and you can read the theory of how it works and then look at the method for how I'm going to do it. Although that method is slightly different than what we're doing this time because we're actually going to adjust the voltage and not the current, at least more consistently. So that's what we're looking like we're going to do here. So I'm going to set the maximum voltage to 5 volts, which probably won't take that long to reach, but we'll just do that because I want to start out low and then I'll increase it. Filling in gaps with a formal statement always helps. Yes, I figured that. That's why I put that together last night because I figured that would really help. Okay, so we're going to be making 2 GPIB device interfaces here. So we're going to do interface ID. That's fine. And we're going to do DMM address And we're going to do PSU address. Create one for DMM at DMM address. Create another object for PSU at PSU address. That's way faster for you. That's hilarious. Yeah. Okay. So for DMM, we're going to do the voltage setup. So I'm going to copy from that. So let's say base setup DMM dot write. Conf DC. Okay, so we're going to set max voltage here. Yeah, upper range. We're going to set it to 50. So you need to change the actual address. Oh, yeah, of DMM. Yeah, sorry. Thank you. Excuse me, 7. That's perfect. So I'm setting the maximum voltage range for the multimeter to 50 because that's the most that the power supply can output. It will never be higher than that. It actually won't be able to measure that high even, so that's fine. And then the lowest range setting I'm going to set to half of a millivolt, which won't matter really, but I'm setting it to that because that is half of a milliamp is the minimum step that the power supply can do. Power supply does not need any base setup. PSU has no base. Actually, the PSU needs to be set to 0. That's right. Let's go back over here. I'm going to do example.py. And I'm just going to grab both of these, two yank, and I'm going to set them to 0. Paste. PSU need to start at, yeah, start at 0. VSet 0. Actually, I'm going to set iset to 10 milliamps because it will never be changed from that if we're controlling voltage instead. Will be adjusted as program runs. Okay. Fixed max value for protection. Okay. I'm also going to come up here and do a C max, and I'm going to set that to 0.00. Let's go with 4. I want to do 4 milliamp. PSU write. Oh, yeah, fair. Thank you. Copy paste errors, they're the worst. PSU write. Okay. So, let's see here. That's base setup, and then we will go into a loop from there. So the while, let's say volts or volt cap. Actually, I'm going to do cap volt. Let's do it based off of the actual thing. Equals 0. While cap volt. I'll do that. Cap volts is less than volt underscore max. Okay. We will be doing a read cap underscore volts equals DMM actually float DMM read, but actually before this, I'm going to have it do a query. I have to have it do a read query. Read. Right, that's it. Read, yes, okay. Also, I'm gonna do this while I'm thinking about it. I would like it to do syst beep when it's done as a alert to let me know when we're finished. Okay. Check if current is lower than desired. Okay, I'm gonna real quick save this. Oh, I can't go back through my Python history. Oh, I can see it here. Okay. So we're going to have, ooh, yeah, I need to set a resistor value. R limit equals 220, 218, 220, value measured at 218. Okay, just grab that for now. So when we're doing this, we will take our currently measured voltage, and we have our target current, and then we will be setting it to that voltage. So let's go back. Realizing we'll end up setting a voltage. This doesn't work. That can't be my limit here. Yeah, no, that's what I'm getting to, Helencroft. I'm realizing if I set the way that I'm writing this program, I'm getting ahead of myself in the code here. I was gonna do, you know, get target voltage, you know, that kind of thing, and then I was going to do set PSU voltage as the next step. But what was going to happen here is we're going to get the next voltage, but the cap volts could currently be right up against the edge of the maximum voltage rating for the capacitor. And then we're going to get a new target voltage to reach the current value, and that could set it past the max voltage, and it will set it to the power supply, and then we'll go through the loop, and then we will check here after loop. So we will set a voltage to the power supply beyond what we should if we do it this route. So what I need to do is I need to add a check in the middle to exit out. I can either do a break, or I could have this be a Boolean. I think I'll just do a break, yeah. Are we using the Razer keyboard with the green switches? It sounds nice. We are, Allo. So if I switch here, yeah, I just, on, clickety, click, click. Okay, yeah, I'm using it on my lap here as I'm typing, because I don't have enough bench space. So yeah, I am using the Razer Black Widow here. Break is easier? Yeah, I'm gonna do a break. So yeah, I am using the Razer Black Widow. I do quite like this keyboard a lot. right, so we'll do a break. Get target voltage, and then it'll be check if target is higher than max. So, yeah, just hadn't noticed if we switched yet. Oh yeah, I did it immediately. So, yoink. If that, actually no, if the opposite of that, break. Boom. Then it'll beep and we're done. Print max voltage reached. Actually, I might as well print that up here. Okay, now I'm going to use the formula there that Helen Croft gave me. If cap equal V limit is break, yeah. So the we're getting cap volts, so it'll be cap underscore volts. What was it? Times? I believe it's times. Yeah. Oh, plus. Duh. Plus. C equal or underscore max times our limit. Okay, and then this will be a new variable that doesn't need to exist for long, so it'll be target, actually underscore volts. We will have to do this, target underscore volts. Okay, if that's all good, then we're going to take this and we're going to put in plus string target yada yada volts. Okay. Can't use target volts there that easily. What? Why? Oh, target volts is the, that's right, because that's the power supply. That'll always be higher. Yeah, okay. So, that complicates things. Realistically, what are the volt steps going to be? You know what? We'll run this. We won't have the check. We'll just do this because we are so far under the rated voltages for this capacitor. We're going to go up to 5 on this first run, and it's rated to 200. I want to see how large of an, what the increments it makes are here. How many steps it takes as it does this. And then we'll see, you know, like how big will it be? Can just add C max limit thing, target voltage, supply voltage, yeah. Yeah, I think you're fine overshooting a little. Yeah, that's what I'm saying, is that I'm gonna see how much it'll overshoot, and then it'll probably be fine. I don't think it'll be an issue. So, okay, I'm gonna do print da 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 da. Trying to think about how I want to do this. So actually, we need to read something from the power supply as well if we're going to calculate the resistance. All right, here's what I want to do. I want to print a header. Print header, and we're going to print cap volts, and we're going to do target volts, and then we're going to do C PSU, because we're going to get the current from the power supply. Watching you code is so cool. Well, that's cool. I'm glad that it's entertaining. Oh, whoops. Not, what did I do? Control R, there we go. I wanted to do, why is it? Oh, that's right, you can't change the size of Vim buffers as easily as like BYOBU or TMUX or whatever. Okay, so C underscore PSU, and I'm gonna have to add that up here. Maybe I'll just do C now. You know what? Yeah, let's name it C now. Yank yank P C now. Let's call it that. Set it to 0. C now. Okay. And then C underscore R will be calculated. I add that. Yank yank P underscore R 0 calculated. See, now we can calculate. Yeah. See now. Helicraft, I'm gonna do. That's going to be read from the power supply. C max. So C max is going to be the maximum milliamps I want going to the capacitor. How are you going to fetch C now? Might be another, no, the power supply. The power supply will, I can get the current rating from the power supply. I'll just do this here. Hold on. Let me get current readings. Okay, so this is, yeah, that's that. And then we're gonna do to yank yank paste. I'm gonna do PSU write, and we're gonna do I out. All right, because if we go over here, the power supply lets you do I out as a command, and then it will return it. C now is cap volts. Hold on. C now. The whole problem is that the PSU is bad at low current. I'm not. Okay, yeah, but it. Okay, I think we're misinterpreting something here. Let me just demonstrate this really quick here. All right, I'm just gonna. Let me save this. We'll just do this really quick. So I'm gonna take. Actually, hold on. Cam's laptop. Okay. Okay, so I'm gonna use the LEDs again here, all right? This is set up so that I can power these directly. I don't need to connect the resistor because it's already in line. So if I connect, let's do VSET 3, sure, that's fine. We're gonna set that to 20. iSet is set to 10, that's also fine. Okay, so connect this here, connect this there. All right, that ripped it out, but whatever. Get it pushed back in. VSET 20, not 80. That will do rude things. VSET 20. Boom. Okay, they turn on. All right, we get, hold on, clickety click click. Python, all right. So, copy the formula here real quick. I want to get 2 milliamps. All right, so we're reading currently 13.47. Boom, I need to set it to 13.9. VSET 13.91. Enter. Okay, we're now at 3.4 milliamps. in there, so that's close enough. All right, it's at least below whatever the control limit is of this thing. I could iterate through that a couple of times, then it would get closer. Now what I'm going to do, what files do I have? I have read amps. Okay. We're going to do read amps. Boom. So there we go. We just read that we're at 2.8 amps because vim read amps. The power supply can read back the current output. So C now is going to be the current coming out of the power supply, and that is the total current going to the capacitor. So that's what I'm trying to achieve here with the C now. So that's C now in my head. Now I do know that current value includes the resistor, but I'm pretty sure that's what we want. So I think we're good there. So yeah. Let's see, bad at measuring or bad at regulating. Okay, hold on. How are you going to fetch? See now, is it going to be another DMM? Yeah, okay. Yes, the series circuit current is the same through everything. Yes, that's it. So, all right, I think we're good. But I think that makes sense to everyone now. We're at the right point, and I could even be super fancy here if I wanted. We'll read amps, and then we'll send it over. Boom, read amps sent. There you go, on screen, 2.8 milliamps. We can also calculate C now, so it should be the same as reading back. So log both values. How are we going to calculate? Well, that is our only current measurement, though. So that's the thing. I don't know how we're going to calculate that. We V over IR. We don't have R unless we have I, and this is the only way we can get I. I'm not sure how. C now is the difference between caps volts and R limit. So what you're saying is if we go Python here, we have a shunt so we can calculate current. Okay. Caps volts. Caps volts. So let us see the code. Hold on here. Oh, sorry. There. So you're saying 13.13, which is the current multimeter reading. All right. Minus 13.13 divided by 220. That's 13 milliamps, I think, or no, it'd be 13 amps because this doesn't. Yeah, V over IR doesn't do that stuff. See now calc equals set volts. Oh, okay, that's different. Wait, set volts minus cap volts. Okay, so I will do boom, 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 and then set volts is 13.913. That's, well, that is super weird. The multimeter is 13139. The power supply is 13913. That is, man, I'm glad I don't have dyslexia. So, okay, 913. Boom. 3.5. That's pretty close. I guess we can do that. Is there any reason to do that when we can just query it? I don't know how accurate is that going to be. Let me do the other math here. So if I want, let's say I want to set this to 5. All right, so we're at 13.14 currently. I want it to be 5 milliamps. Okay, so 14.24 V set. I can't do it there. Actually, just local. V set 14. Hold on. V set 14.24. Enter. Okay, it's at 4.0. I'm going to rerun this. Measured is 13.22 actual is 14.247. That seems regularly slightly higher. More data to log is better. Yeah. Well, yeah. There is no reason not to. I don't think value would be precise enough. An average between them may help, I guess. Yeah, there is no reason not to do it. So I guess we can. All right, let's quit that. Go back. It's, oh man, that's... Okay. Yeah, I need a little more space. So let's say I increase this because there's some wasted space over there. Ultimately, I don't think there's a resolution here to find the value you want. Resistance to be reasonably accurate. I don't know how bad it's going to be off. Actually, I think I can close this. I have everything I need. Which means I can make this bigger so it's easier to see. And there we go. One of my favorite little tricks here, I have custom specified Vim everything. That's how I'm able to tab a file browser. One of the things I do is on the right here is a slightly less than black strip so that I know where 80 columns is. So that's my little quick cheater way of knowing if I'm getting close to breaking the 80 column limit. Okay, so we'll do see now and I guess yank. Hold on, yank. I don't care about a mark. What do you, stop it. There we go. No, undo. Yank, see now, C. That's what we'll do. So, you have around 0.5 milliamp resolution either way from what I can see. Oh, that is something, yeah, which will give you resistance to the nearest half meg. Half meg, really? That would be bad. Well, we'll see. Oh man, I'm gonna have to calculate resistance twice now based on each value. Well, we'll find out how it goes. Okay, so cap, I was doing I out, and then we're gonna do PSU. I don't actually, the PSU just reads it back as plain text. This will probably work. So C underscore now, then we're gonna do C underscore now, C equals, and then it was C, or hold on, that's target. Oh, I need to read the current output voltage. So actually I need to do yank, paste. I guess we're doing V now. Yank, V now. Because I'd rather read it back to see what it's actually currently set at. V out. V now. Okay, so C now, C equals, it was set volts minus cap volts. Yeah, so V underscore now minus cap underscore volts divided by R underscore limit. Yeah, okay. All values we calculate from the start, calculate start from the DMM, and that has a lot of precision. The DMM should be good. It's just, I don't know when it was last calibrated, but, you know, but meh. Okay, so C now, okay, C R, oh, that's cap resistance, okay. Did I just add a V now? That's not, no, oh no, that's, oh man. I'm not happy with these variable names, okay. I'm fighting my urge to go object-oriented and make a bunch of classes and stuff to wrap the multimeter in the power supply, because that's a nightmare to making this code take forever. So let's change this. PSU underscore vnow. This will be cap underscore C. No, PSU. PSU underscore, oh my gosh, stop doing caps. Cmax will be cap underscore Cmax, because that's not the maximum for the power supply. Volt max is cap underscore volt max. Cap underscore C now. We're calculating that across the everything, sort of, because that's not that. Cap underscore R is good. R underscore limit. R is fine because that's a resistor. Okay, strictly speaking, current should be I and voltage should be E. I have never seen voltage as E, ever. That might be an industrial thing. I will agree that maybe I should use I because the commands are I for stuff, so I will switch to that. I've never seen E though, but ultimately, as long as you know what's going on, you can understand. Yeah, I will standardize to the command set. How about that? The commands are I and V. I'm curious about the E though. It's technically correct, the best kind of correct, yeah. In Germany, voltage is U. Oh man, yeah, V set, I set, yeah, I'll standardize to that. Cap I, okay, all that's correct. I'll go ahead and standardize to single letter units across everything. Cap V max, okay. Okay, cap V, target V, who is cap underscore I. Now, everything for voltage I've learned in school is E for electromotive force. That sounds very industrial setup. Okay, and then this is cap R. Actually, hold on, how do I want to do this? We got a lot of stuff to print. So we're calculating I, so we'll do C, or cap underscore I underscore now C, and then cap, you know what, I will put C at the end of cap R because that is calculated as well. Seeing RC like that kind of bugs me, but we'll just ignore the fact that that means something as well. Okay, target V. Okay, technically E is a voltage from a source, V is voltage across a component of the circuit. Okay, at least up to here in Canada, interesting. Brief relief, thank you for the Prime sub, I do appreciate that, and that will help a lot. Okay, what else are we logging? We're logging the cap voltage, we're logging the target voltage, also, you know what, let's change that to PSUV. PSUV. Now. Cap I now. Actually, it was PSU I now, isn't it? PSU I now. Yeah, and then cap I now is C because it's calculated. And you know what? I'm going to go ahead and move all the cap stuff to the front. And I copied that, I didn't delete it. Okay, power supply, and then yes, the DMM gets cap volts, so that doesn't have a specific thing. So cap V. Okay, that is. Oh, Bodband, thank you for the tier 1 sub and for the 3rd month. See, what is this, Python? Yes, this is in fact Python. Yeah. So this should be PSU underscore I now, and then it'll be PSU underscore V now, and with that we can calculate cap underscore I now. Okay, target underscore V is cap V. Cap underscore V max, right? No, hold on, what was that? Is that target voltage? No, that's I max. Yes, okay. It can be nice because then you can say things like, okay. Target V, okay, that's that-ish. What's going on here? Oh, I don't need that. Oh, there was the log line, that was it, okay. That's fine. Yeah, so the only lever we're changing, the only output, the only thing we were setting is the voltage on the power supply. We're not touching the current, which is actually better because that is allowing us to modulate the current in higher precision. Okay. So that's good. And because I'm using such a low resistor value, it means that the maximum voltage we can reach is not that reduced at the capacitor. So, okay. See, only reading the current back to using calculations correct. Technically, it sounds like we don't even need to do that. I'm just doing it because I can. Because we can also, that's right, we need to calculate cap IC now. So, no, we're doing that right there. V now minus cap V. We're basic, yeah, just, we're reading that back to, actually, we were going to calculate, that's right, we have to calculate resistance. Cap RC, oh no, that's right, underscore, we can calculate two separate resistance values. Use calc cap underscore R in V now. Hold on, where? There's a V now. Oh yeah, you're right. Thank you. I hate non-object oriented programming. I really want to wrap everything in object oriented getters and setters, so like every time you try and read power supply voltage, it just goes and gets the power supply voltage. This is a mess, this is a mess. I'm not happy with this, trust me. This is going to be quicker than allowing me to go make it all object oriented, which I will be doing tonight, don't worry. I will be wrapping everything in nice, pretty object oriented program or code tonight. Should have written it in Java, only if I hate myself. Okay, so use calc cap R and calc cap. Alright, so yeah, you know what, maybe that does make sense. We'll do, but no, we'll both, that's the thing. Both resistance values are calculated. We're gonna calculate the resistance based off of the actual current measurement from the power supply, and we wanna do it based off of the current calculation based off of the voltage difference in the known resistor value. So that's the thing. That's that we're doing. So we have calc, so we would have, I'm gonna do calc, I'm gonna do cap RC P for PSU. Oh, I hate this. And calc, you know what, I'm typing out PSU. Insert PSU, okay. Calc RC PSU and calc, or cap RC calc. That's what we'll do. And I'll just get rid of the C because that's kind of excessive. Okay, I'm gonna, oh, fanboy, yeah, me too. Well, OP doesn't magically solve naming problems? No, but it can make its stuff a lot easier. Because I'm basically doing object-oriented style naming by just having everything as underscores instead of periods. So, yeah, total sidebar reminds me of Viper7.com to go to lol. People kept asking me why adding go to PHP was bad, so I wrote XML parser and using only go to. The thing is every bit of compiled code you write uses go-tos and you just don't know it. So, unless someone has written a C compiler that doesn't use jump statements, but I want to see that happen. Okay, calc R, okay. Yes, okay, so now I need to do the V over IR, okay, so, okay, cap underscore R, we're gonna do PSU. Okay, V is cap equals cap, processors really only, yeah, they literally only understand go to if you think about it. PSU, okay. No, cap V, cap underscore V for IR, okay. I would be PSU underscore I underscore now, okay. And then cap calc would be cap underscore I, all that stuff, that, okay. Then we have to print that. Cap R PSU and cap underscore R calc. Okay. Is that everything? Cap V, voltage across capacitor. Cap I is, now C is from the calculation. Okay, I love the standards XKCD comment. Yeah, needs to print header tell that this is the header actually. This right here, that's the header. Helen Croft. So that is it. And then I'm just going to copy and paste that line down below and remove the quotation marks and replace all of the commas. Oh, I'm going to have to add more complicatedness, but it'll be fine. I'm just going to remove the, I'm going to convert this into the variable actual print statement here in a moment. So using high-level scripting language will make the code readable. You don't, yeah, inline ASM and Excel. Oh gosh. Okay. Okay, let me look at that. We have cap V, check, cap I now C, check, cap R PSU, check, cap R calc, check, cap PSU V now is there, yes. Cap PSU I now is there, okay. And I think that's everything that's going to change. The max values are set. So is R limit. I'm going to move R limit up there. Paste. Everyone's concerned about go-to. All's really about where all the code comes from. Yeah. Okay. Let's make our print statement. I think that's everything. Yank, yank. We're already, ooh, cap volts is still wrong. Hold on, and volt max. Cap V is greater than cap underscore V max. Okay. Yeah. Cap V max. Okay, that's good. Now let's do our print statement. Print. We'll paste. CD. Indent. Okay. Now the fun. If I was really feeling fancy, I would just do a substitute on this line, but I'm not feeling fancy. I'm just going to do this because I'm feeling lazy and like making things complicated, but I will be slightly fancy. Here's what I'm going to do. Yank that. And then, actually, you know what? I'm going to insert. Oh, you know what? No, I can just do P. No, that didn't work. Okay. Insert, delete, plus, no. Yeah, no, that was right. Plus equals, comma, no. Idiot. Quote, no, plus, quote, comma, quote, plus. There. And now I can just press period over the quote. There we go. Vim, I tells ya. Get good variable names for writing code. Yes. I think I have them, maybe. Plus equals comma, no. Yeah, yeah. This kind of thing is why I would never code live in public. Yeah. No. Yeah, exactly. This is not fun. That should be good because we're printing a string. Oh my gosh, I gotta wrap all those in strings. Oh no. String that. I'm doing this. I want to do this, and then we'll just put the closed parentheses on there. I hate Python. I hate that Python is the best option for something like this, and that Python is dumb. sprintf would like to know your location. Would sprintf just fix this and I wouldn't have to do it? Templates are for suckers. Would sprintf just allow me to do that and I wouldn't have to do all this string nonsense? Because if so, I'm going to never use print again and I'm just going to use sprintf, but I probably have to import it, don't I? I don't know Python. Okay. Does it really need wrapping in string? Yes. Why not use string? That formatting? I don't know what that is. Print every variable after calculation. Don't do a line feed so they end up after each other in the same line. That would be smart too, but then I'd have to look up how you do a no line feed print in Python, and I didn't want to have to do that. So there we go. That's that. Done. We got it. Vim, reform. That should be it. In all of its hideousness. So there's it all on one line that's way longer than 80 characters. Yeah. That's a thing. Close it up and never open it again. Format. Oh, that's interesting. I'll have to look at that later. See, can't concatenate. Intensifies, yeah. Also, hello, Epic Time X, since it's your first time chatting. For no new line. Ah, okay. Well, thank you for Otaku No Podcast. I'll try and keep that in mind. How long have I got? Okay. All right, I think that'll work. So let's go ahead and try that on our capacitor. I'm gonna do vset 0. Let's do this. Why is that not all working? Oh, because if it works, it works. Yeah, exactly. We're gonna go back to this. vset 0, enter. Okay, iset 0, enter. Okay, I can now safely connect this to the capacitor. All right. Positive, negative. Let's just do negative first since there's a stripe. Makes it nice and obvious. Okay. Positive. Boom. We all ready to see what happens? You know, Actually, let's just real quick. Let's run it without a capacitor connected. It should like cry, but let's just see if it has like syntax errors. Also, I should chmod plus x reform. I'll let you see it here. Reform. Yeah, cap v is not defined. What? How? It's like the first thing that's defined. It's not defined. Cap v equals, okay, well, let's just do cap underscore v equals 0. There, problem 1 solved. Hope once it's been reformed, it doesn't reoffend. It should be fine. There's also F strings. Don't want this cap to launch off like a rocket. That is a potential if I really mess something up somehow. I don't think it'll happen. There we go. Oh, that's cool. And it ended. All right. That's interesting. So cap V, it slowly raised the voltage, it seems. Okay. That's interesting. PSU I never changed. PSU V changed. Okay. So there's example output. What is cap underscore volts? There is no cap underscore volts. I got rid of it. Cap V is cap underscore volts now. I don't think there is a cap underscore volts anywhere, is there? No, there isn't. So yeah, that doesn't exist anymore. You're confusing me. Which is fine. This has been awful. So yeah. Okay, I think it'll work. Let's do it. I'm gonna go to cams, and here's what I'm gonna do. I'm gonna stretch that so you can kind of see it at the same time. And I'm just gonna put it up here. That'll work. I'm gonna hide that because that's not actually updating. Hopefully that's like legible-ish. All right, connecting. Boom. Hold on. This is set. V local V set 0 enter. I set 0 enter. Okay, now it's off. Sort of. Connected. Multimeter's not updating because it's set to remote. All right. Let me position this all. Here we go. Boom. Oh, I vimmed it, not run. Run! Well, that was quick. Okay, it's reformed. We're all good. What happened? That's clearly not right. Let me get the cap off. Cap, the current never moves up. Oh, am I supposed to do a check on the current? I probably am. What if it's just charged? And then it won't take any current? What if this voltage is way too low? Broadband, I like that. I'm doing that right now. Boom. Okay. Can you discharge it first? We can. I suspect it's going to charge pretty quick. Boom. Okay. Discharge via screwdriver. Point this down and maybe attempt to tighten that. Okay. Hello, Welsh Boy 2008. We'd nice to see it run a while in a steady state at the end to see how the value settles. Well, that's going to take different logic. That's the thing. Well, it's discharged, so the last value there is the actual current. And it was reading like nothing. That's set to 6 volts still. Hold on. Local V set 0, 0. I set 0. Boom. Now I'm going to short it again. Just be sure. Boom. Maybe I should set the I max really, really low. I'm gonna run it again. Took longer. I'm gonna run it and I want to watch the power supply. Yeah. Let's see. And before angry comments about discharging cap by shorting. Yeah, meh. 5 milliamps is gonna charge it pretty quick. All right, I'm gonna set it to 2. Actually, it's set to 4. I'm gonna set it to 2. Boom. Well, that lasted longer. And is it going to discharge it? That would be really handy if it's discharging. This is really fast. You feel like a Zoo Player's taking a jam session. So, our current PSU I now at the back end keeps like dropping down, or changing. You know what? I'm not printing the target. So, hold on here. Target V. I'm going to print the target V. Although, I'm setting that to target V. I don't think target V is really needed. You know what I would like to do, though? I'd like to print with some tabs. So stuff gets separated. Although it's doing it all as like super ridiculous scientific notation. All right, questions. Anyone know of some kind of Linux command that can format CSV formatted data on the fly for output that I could just pipe this into? Because that'd be pretty sweet. Cap volts on line 32. Where? Oh, there is that. Okay, well, that can just go away. It's interesting. I feel like this is not going slowly enough. I seen you did some testing at 3 a.m. Fell asleep, left the PC on. Oh man, that's unfortunate. This comes out to that time for you there. Phallic. Yeah, I'm just doing this kind of middle of the day for me. Python has built-in CSV formatting library. Yeah, I just wanted to pipe it to something. That's it. Honestly, the terminal output of the script is pretty much CSV already. That's what I'm saying. I wish it was... how many times do you have to do this to a cap to recondition it? Once. That's the thing. That's why I'm a little concerned at how quickly this is happening. It's just taking on the current super duper fast. Column, Google suggests column ST. Okay. Well, I will try rerunning this. Is column a program? Column. It is. Ooh, hello. Dash S, comma. Okay, that would be the delineation dash T. Okay, so we'll do reform pipe. Boom. Well, it waits until it finishes, but that's something. How can I do it on the... Oh, man, that's nice, though. I like that. That's super cool. It doesn't quite do it on the fly. Round. Yeah, that would be a good way of doing it. Hellcroft, but we got... Change comma to T. Well, that's the easy way, too, but I didn't set it as a variable, so that'd be a pain. Make this TSV, set CSV. Yeah, this is news to me. I'll need to remember that command. Yeah, that's pretty nice. So, RPSU, whoa! Why is the cap RPSU so wonky? Something's not right. But look at those values. That's a little weird. Let's read the code. Yeah, so cap R PSU. Cap R PSU is set here. Cap V divided by cap I now. And cap I now. Oh, I know exactly why. Okay, I got it. Because the power supply is reading a negative voltage because it's so low. That's what's going on. Okay, so that's fine-ish. I really wish this would print in real time. Yeah, that's totally fine. You know, could I do... Is there a way pipe without waiting for the program to finish? Linux pipe before exit. Well, actually, this should be working. Is it just because column wants it to all be formatted? Rubber ducking is the best. That's basically what I'm doing here, yes. Haskell lazy CSV utils might do what you want. Yeah, okay, so you see the PSU current measurement is useless. That's why we calculate. Yeah, I guess so. Huh. So cap I, yeah, that one's actually a lot better. Interestingly, so I'm setting it to 2 milliamps. Let's set it to 3. Let's rerun this. What do we get? We're going to brush up against 2 milliamps? Yep. Okay, that's really interesting. All right. Wow. Okay, well, I'm really glad we went your way, Helen Croft, and did the calculated current. Huh. All right, I'm going to set it to a higher voltage. I want to see what happens. I'm going to not print it as... might wait to determine the max column of the width. Oh, yeah, that's probably it, huh? Let's see. Man, column. Truncate. Specify columns for text to be truncated when necessary. Otherwise, very long and table listers may be printed on multiple lines. Output width. Meh. Let's just T it. Oh, we could T it. Can't we? Can you T print? Let's see, measure current. Yeah, it's so bad. It really is. Yeah, can I T? Man, T. Append, output, so I think, yeah, if I do T, boom. Nope, that didn't work. Ah, fine, I'll do it. Damn reform. All right, let's just do this. It's gonna suck. Actually, you know what? Screw this. Let's do. No, stop recording. Insert tab. D equals T. Yeah, I tried T. It didn't T to STD air. Ooh, hold on. I like that. T dev std error. I have to add a, it's append, isn't it? Oh, it still waits. It still waited. That is so weird. Why? That won't just write to a file called T? I think the code is working, yeah. Easier way to, oh man. All right, FG, let's do this. Plus, oh, hold on, let me start there. Okay, insert 1, 2, 3, D. Okay. I guess this actually wasn't that bad. Because now this is just gonna be simple. Oh, I do have to do this slightly different. T to... Oh, all right. I'll try that before writing, just out of curiosity. Not writing. Nope. That's so strange. And then it didn't pipe it. Right. Okay. Quit. And then we'll just run it. Boom. Oh, it sucks now. There we go. Sort of. Close enough. Yeah, then we have the inconsistent widths of the printouts. That's why I didn't really want to do this. The columns output is so much better. If I could get this to work and then use the, I think I can do that. Yeah, so, oh, that still sucked though. Oh wait, I gotta get rid of STDR. So if we can figure out how to make it print, no, that sucks too. What gives? Wasn't it really nice up above? Oh well, whatever. We'll just go with that. All right, I'm just gonna fly with that because we're getting close to the time that I want to call it here. So I'm gonna do Vim Reform, and I'm gonna set the maximum voltage to 25. Actually, set it to 15. Set it to 15, and I want to see what it actually does here. Column output is only better because it waits until end to print. Yeah. So, okay. I'm setting it to 15, and we're going to let it run. Set it to 15 at, whoa, no, at 1 milliamp. Out, local, out, off. Okay. Yeah, let's do 15 at 1 milliamp. I want to see this take a while. You know what? I set output off, and I don't think my code doesn't turn it on. So this isn't running. What's the cap rated for? 200 volts. So yeah, we're good. Okay, we're gonna rerun this, and it's actually gonna work this time. Okay, so it is very, very slowly raising. You know what? I can do even lower values than a milliamp, can't I? Like, I could do 100 microamps. I'm not cutting off output, it wraps. So it would only wrap over, not cut off. It's the width of the first column changing that's shifting everything over back and forth. Okay, which is our calculated current? It's this first one there. So we're, yeah, okay. Now this is the slowness that I actually wanted here. I like this. So we're probably gonna do, even though the DOT thing says we're gonna do it at 10 milliamps, I think I might do it at 100 microamps. Because I like this. I love how slow this is going. There are some pixels cut off on the left. Oh, on the left, yeah, possibly. You know what? I can fix that here. There you go. That should, yeah, like that, I think is good. We're only seeing half of the first digit. What do you... Oh, okay, I got it. That's fixed now, I think. Yeah, so Viper 7, that's the traditional way of doing reforming. This is on a good cap. It'll be even slower on a bad cap. Well, we don't actually know it's a good cap, although it is from 2010, so it's probably okay. The power supply was dead. That's why I took it apart. I don't know what killed the power supply. This cap's probably okay, though. You know what? I'm going to make a modification here. Are we playing? We are playing good cap, bad cap. Not really. I'm going to make a modification here where if the current, I guess, let's go with the one that's R calc. If it's less than the current that is the current max, then it doesn't change the target voltage. Because I want to see it actually raise to the current max and then step up. I want it to take... Yeah, is leakage much of an issue on modern caps, though? It's not really... we don't need to reform this cap. I'm only using this cap because it's a good test subject. So, yeah, if it's a slow charging thing, doing the difference, I'd think think running 100 cycles at 10 milliamps would do more than one cycle. I'm trying to figure out the best way to phrase this for you Viper 7. The reason you set the 10 milliamp limit is because you expect it to pull 10 milliamps and that you can see that on a cheap meter, on like an analog, like the Simpson meter I have somewhere over here. I don't see it too quickly. Oh, it's really far away. Like you'd put that on a cheap meter, all right, and you'd see 10 milliamps pop up. And then as the cap reaches the voltage level, that will drop down and then you won't be able to see it anymore. And then you turn up the voltage slightly again. So the reason you do that is just because you need to be able to see that meter bounce up to 10 milliamps, then slowly back down. That's why you do that. This is effectively doing the same thing, but linearly instead of in steps, and then it drips down, and then a step, and then it droops down. So we're effectively doing the same thing. So that, yeah, that's what's going on here. I don't know if the dwell time is that important, but what I want to do is I want to add some of that step. So I want to bump it up to a little bit and then watch it droop. And yeah, maybe that's what I should do. If, maybe if it's less than 30% of the max current, if, yeah, so maybe I'm going to add a step percent amount. Let's say step underscore target, I don't know. Step underscore low, sure. Equals 0.3. All right. So I'm gonna say we're gonna use the apparently better calculation now. Preferred value. See, step delta. Yeet. Well, the step delta might be the current, the one that we'll be using to checking at step low. So if it gets below step low for the current, then we're going to bump it up. But so what I'm going to say here is if cap oh my gosh, cap man, these variable names suck. Who did this? Calc. What? Cap cap R calc. No, hold on. Cap now C. Okay. I underscore now C. Okay. Remember we calculate the current before we increase the voltage. Yes. Yeah, because I want it to dwell on the same voltage. So I'm going to... Oh, Blake GJ, thank you for the tier 1 sub at 4 months. I'm going to... see, we want the current after the new voltage. No. So what I'm trying to do is I'm trying to prevent it from raising the voltage if we haven't put enough current into it. So, okay, let me do it this way. So if we go back to, where is it? This, okay? What I'm looking at is these steps, the method for doing the reforming here. So step 1 is connect a weak capacitor at 0 voltage, okay? Step 2 is increase voltage by a small percentage of maximum rated value, and we're doing that with the calculations that we're doing. Watch current taken in by capacitor drop as current reforms. So this is what I'm talking about. You watch the meter drop down from 10 milliamps down to 0. Then when current drops significantly, it has been formed up to that voltage. So if we set this cap to 5 volts at 10 milliamps, and it would immediately be at 10 milliamps, but then it would drop down to 0 as the capacitor gets up to 5 volts. Then we would know we could step it up to 10 volts at 10 milliamps, and it would peg up to 10 milliamps and then eventually slowly drop down. So what I'm trying to do is I'm trying to add step 4 to this, because we did not do a step 4. We were just slowly increasing it, kind of unregulated, just by saying that this is the maximum current. We don't really have anything that says slow down, we need to wait for the capacitor to charge. So if cap now C is less than cap underscore I underscore max times step low, so that'll be 30% of cap max. If it's less than that, then we can increase the target voltage. Now, one problem is that we're doing this at like such crazy low amounts that this might be slightly problematic, but we'll see how it goes. I should probably print target V now, though. We can see, though, it's somewhat stabilized around 0.3 volts. So it's not... It doesn't seem to be taking in any more current at that. So what I'm going to do, I will tune this. We'll say we need 40%. All right. I'm going to just local out off short. Boom. Okay, capacitor should be discharged. On. And then begin the reforming. So it should... It's not really dwelling a whole lot. There we go. So dwelling for a bit at 1.3. This will, so maybe add a delay. Well, I would really like it to be based on the amount of current that it's pulling in. That's the thing. We can see there, it is, I think it's slowly pulling in less and less current. See, I'd be interested to see how this behaves with a small step size, but a very high allowed current. Yeah, actually, I would like to try that. So let's say Vim Reform max current is 1 milliamp, and our step size is 10%. Actually, that'll be almost immediately because that was our max. Forgive me for being a bit of a Twitch derp. Take it, channel points cannot be turned into bits. No, they can't, Starhawk. So the channel points are meant to be the free way to interact with people, and then bits are the way of supporting a creator. So that's basically what that is. Okay, so if we do 0.05, so that'd be 5% of 1 milliamp, so that'd be 50 microamps. That seems a little low. I don't think it'll actually reach that. Let's go with 3 milliamps maybe, and then it has to reach 1%, no, 10%, which would be 300 microamps. No, but let's go 5%. Let's try this. That's going real quick. Okay, I think we're gonna go slower. Step low, 1%. Something doesn't seem right. That should have taken longer. So the problem is if we go too low, then the leakage current of the capacitor just heating from having current applied to it will register. And it's looking like it takes about 40 microamps just in leakage current. That seems to be what we're getting. We increase the current 30x. Yes, to 30x. It's not set to 30 milliamps, is it? It's 3 milliamps. Yeah, so 3 milliamps. We could also do, we could do it this way. Cap I, let's set a minimum step. So let's say 3 milliamps is where it jumps up to, and then 0.5. So 500 microamps. Let's say 50 microamps. Let's try that. So we started out at 3 milliamps, all right, per step, and then it's allowed to go until it reaches 50 microamps. I don't think it'll actually make a step. I think it'll stop. But let me change this. If cap I now C is less than cap I min. So we'll do it this way. We'll just do it direct. That doesn't feel right. Do we need to make it smaller? Like 25 microamps? I mean, as voltage gets higher, allow more leakage. That's gonna be complicated. Let's see. Take a while to save 100K. Yeah, it will. That's intentional. I don't suppose DMM has another channel? No. So, yeah, if we set it too low, we always get stuck at 1.3. Oh, man. This is a complicated one. You think the DMM is on the wrong thing? What do you mean? You want the DMM to be doing current measurement? Because it would actually be really high precision for that, but then we won't have an actual voltage at the capacitor. We're struggling because we're calculating shunt voltage from supply voltage. Yeah. If we know for certain that the supply voltage, we could calculate the capacitor voltage pretty easily, and then even give ourselves some headroom to make it slightly lower than what we think it should be when we calculate it. Then we could use the multimeter as an ammeter that is much higher precision. Yeah, maybe we should do that. Yeah, because the capacitor voltage is going to have a more forgiving tolerance. The tolerance range may not be as high as, say, the capacitance range, but if we step over it a little bit, it's not going to be the end of the world. And we could always undershoot by saying that the supply voltage is the max. So, It's going to be a fairly significant change that I don't want to do today. Compensate for leakage, we probably need both voltages with precision. Yeah, I really, again, if I had another 34401A, we wouldn't even be talking about this. We would just have current at high precision. We'd be doing the voltage and the current both with high precision. If I had some kind of switcher that I could switch them back and forth, we could do that. So yeah, what we're stuck with is the low precision power supply, but then the high precision in one point. So yeah, it's now a 4-hour stream. Yeah, I'm gonna be wrapping it up here. We're not making any big architectural changes to anything. So yeah, I do want to do one thing. I'm gonna set this to 4.5 microamps or 45 microamps, and then I'm gonna run it, see where it goes. Why was there an error? So we can definitely see it's doing what we want. If we look here at this, can I Alt? No, Control, Shift. I thought there was a way to like only select, there we go. Okay, if we look right here, okay, we can see that the resistance, oh no, that was a bad idea. Where am I at? Okay, if we look right here, we can see the current gets set to a max of 3, and then it drops down to well, it gets set at 2.6 milliamps, and then it drops down to 300 microamps, and then from there it drops down to 4.6 or 46 microamps, and then it goes below the threshold, and our calculation fails, so it steps it up to 3 milliamps again. So it is working. It's just not doing, it's going, it might be actually that the capacitor's good. That might be what it is. That because it's good, it's doing well. You know what? We're gonna set this to like a super high voltage. Let's get up into a voltage range we haven't worked at. We're gonna set this to 25 volts and we're gonna see what happens. Once it gets above 15 volts, we should see it take a little bit longer to work. Okay, and we're into fresh territory. That still didn't really take that long. It's still doing it in like the 3 steps. So it spends 4 cycles on it. Cody, I think it is working. I think the capacitor's just not that bad. Blue Murder, we are so far under value on this thing. You know what? We can just, for giggles, let's just set it to the max we can do. Cap max voltage 50. The power supply is going to complain on this. You know what? We'll do 45 because then it won't complain. This is way higher. We might actually see some real changes here because this is a 200 volt cap. Good cap is still good. Yeah, I think you're right, Helmcroft. I think this is a good cap and it's just charging quickly. So, yeah, there may not be a whole lot we can do to make this one look bad. I think aside from wanting to rewrite the code to do a little more checking maybe or some other things, at this point we should connect a known out of spec cap. Because yeah, this one seems pretty good. Yeah, this one seems like it's fine. And realistically, we are so far under its rated voltage that even if it has degraded, we may not even be getting past the part that it's degraded to, because it could be now only a 150 volt cap instead of a 200 volt cap, and it's just going to run fine. So I think that's what it is. We would have to connect an old cap at this point. Hold on. At this point, would not be better to set up your script to pass args from the command line, or was... So I may not use arguments. I might let it read the input from a text file, and that you could pass that as an argument. But I think I want it to be a thing where you deliberately have to save the rated capacitance of the capacitor, and that you look at that rather than like quickly type on a command line and then accidentally set it to the wrong value, because it's going to scroll away really quick. Another thing I may do, I may look at using N curses and have this all print in like a nice like window, because we were going to have that when we were working with LabVIEW, but we've already made so much more progress in Python than we could possibly with LabVIEW. So this is clearly the way to go. But I think that maybe, well, hold on here. What was I trying to say? Just might be faster. Yeah, get GUI 0 in here. Is that a thing? I might look into some of this stuff tonight. I'm at the point where I don't think I should write any more code. Matter of fact, git add dot git commit add initial reforming script. So git push. So the code is now in the GitHub repository. You can do ! code if you want to get a copy of that file I was just writing. So that's now there. But yeah, I think I'll look at GUI 0 so you can make GUI. Okay, so like Qt or something. I don't really need a GUI. I'm kind of okay with terminal. But that's an interesting concept. So you can do something like reform cap, where cap 1 has specs for a particular capacitor. Yes, that's exactly what I'm talking about. Something like that. Because I want it to be very obvious what the capacitor voltage is. If we do, you know what, maybe we can have it pass as an argument, but I'm going to have it print it back to you and make you press a key to start, if we do that. See, by the way, the Python way for output, I still... it's nasty. This is not good. Oh god, that is horrible, Viper 7. That's the Python way. Blech. Gross. Give it a wrapper TUI. Is that... I don't know. I'm going to look into... I know there's a Python N curses wrapper. I'm going to look for something like that first. Reform 15 volt .py or 35 volt. That would be the worst thing. Duplicates of those. Text user interface. Okay, yeah, that's basically what N curses is. Yeah. I think we're pretty much done here. Unless I can dig through this bin and find a possibly older cap that I don't care about that we could connect to this. I don't think there's one in here. I found a transformer that's almost like a capacitor, and that it's not. Yeah, I don't think I have any old caps that are handy that I want to do right now, because I think we should make the user fill out a capture to start. Yeah. Yeah, I think we should probably call this from here. So I'm going to go ahead and do this. Go back to this. We definitely made a tremendous amount of progress. I'm extremely happy with where we're at. This is actually even better than I thought it was going to go, since we, especially thank you, Helen Croft, for pushing me to do the current limited resistor version. This is much, much better than what I was going to do without that push. So I'm extremely appreciative of that. But yeah, this is definitely on a good track. We are making some real progress here. And I think we may need to tweak some things in a bit here. We won't probably have the cool double probe going on in the future, because we'll probably use the 34401A. We'll probably do it the way it's shown. I think I lost it here. Probably do it the way I was showing it on the graph, the schematic. So we'll put the 34401A, you can't see what I'm talking about at all. We'll put the 34401A in series, measuring current, so we can get the higher precision current value, because I think I agree that's more important right now. And then we'll calculate the capacitor voltage, which will be less accurate but not as critical. So I think that's the way to go. You know what? For grins and giggles, let's get a resistance reading on here, because I would like to see what the capacitor is currently at now. So, just off and on. There's a proper way of setting it back to local, but it's easier to just do that. Okay. So the resistance value, cap log 01, it started out for, this is capacitor 1, it started at 280 kilo ohms. All right, go to C here. So let's see what it's at now. Negative, negative, it's probably the same. Boom. 2 watt. That's the power supply, not the thing. Negative, positive, should be nearly the same. How is it lower? What? Well, that completely invalidates anything I was saying. Oh no, there we go, better connection. Slightly lower, so it's roughly the same, basically. So yeah, we didn't change anything. We probably didn't get into any of the degraded dielectric on this, if there is any. There probably is, but I don't think we got into it because it's such a high value capacitor. But yeah, I am thrilled with the progress we made. We didn't get to the floppy drive. I was really hoping we'd get to the floppy drive, but you know what that means? That means we're doing this Wednesday too, because I think I want to make this my primary focus for right now. I really badly want to get capacitor reforming just absolutely nailed down. I don't want this to be questioned. I want it to work the way that it needs to make this safe and effective. And I think that I should just keep at this for a while, because this is going to lead into all of the vintage computer stuff happening. Yeah. Ran out of time. Yeah, 2 days to rewrite the code. Yeah, I will be doing that a lot. I will be cleaning up the code. So I'm not going to change any functionality right now. I might adapt it to allow us to switch our calculations better. So ideally it should run exactly the same. You want to use the original caps? Yes. Yeah. OLN, I seem to cover this every single time. I mentioned that I'm going to reform the caps and everything. I'm estimating that in today's market, if I had to replace all of the capacitors in those that are just the main power filtering caps after the transformers, it might cost me $800 because they're enormous. They're absolutely ridiculously huge. Look up like a Sprague 72,000 or 27,000 UF capacitor, and you'll see what I'm talking about. They're like $30 or $40 each. So, yeah, coffee mug caps. They're gargantuan. Maybe a reform command. New variable volt or current setup. What do you mean, Helen Croft? By controlling either by current or voltage? Because I think right now, going by limiting the current and then stepping up the voltage is probably the way to go. But how you connect? Oh, yeah, that's not a bad way to go. Yeah, we can do that. We can set it up to allow that. So I am going, like I said, I'm going to go object orient everything. And there's going to be an object for the multimeter for getting and reading values, and then an object for the power supply. And from there, I can then plug those objects into different roles. So we can do that. I think that'll probably be the easiest way to do it. So we'll write the code in a way that makes sense. So yeah, but I'm pretty darn happy with how this is going right now. And I might also have, if I can figure out end curses, or maybe at the very least just do a carriage return print instead of a new line print, and do tabs that way, and then have it logged to a file. That way we don't have all the stuff like scroll by, and then we can open it in like LibreOffice or something to view stuff. Just make it a little bit easier. So that's why what I've always called them coffee mug caps. Yeah, definitely. So, but I think this is it for now. Again, a huge amount of progress. I'm extremely happy with all this. Have some good steps to move forward on, but I think if we ran this right now as is, it would probably work to reform a cap. It's just not ideal. And we don't have a good way of testing that at the moment, because the thing is I can't just go buy old broken capacitors. So I need to actually do it on things that I care about, and I'm not satisfied with how it works right now in that I feel like it's going to do what I want it to do. I think it would work. It just might run a little bit faster, maybe not be as high quality of a reform. It won't build up the layer in the way as slow as I want, and I think going slow is really going to help. So I think that's what I need to make it do, is make sure that it's doing it at the correct speed and have it determine its own speed, but I want to make sure that it's the correct speed. So I think I've got it across. I'm just I am nervous about running it on all of the expensive old stuff. It's just going to be so nice when it's done, and I want to make sure I do it right. So all right, ham radio swap meets for getting caps for testing. That would be interesting. I don't know of any. There are electronic swap meets here, but they are very, very infrequent. And the one time I went, the scale of the old vintage stuff they had was so bad that they actually gave me some CRTs for free because they just wanted them gone. So yeah, they're not really trying. They don't have a lot of vintage stuff in those kinds of places around me. So yeah. Let's see. Maybe you can find an old radio or something with caps to test. Trying to think. Unfortunately, I think everything that I currently own like that, I've already plugged in, which means that they will have reformed their caps, whether they should have or not. See, I envy you, but maybe you can try more another time. I don't know. It depends. We're probably going to be done with defining this by the time there's another one of those events. So I think we're really close. We are so close to having this nailed. So I think that just maybe 1 or 2 more days will probably be it. So yeah, but anyway, I am going to wrap this up here. So let's go ahead and run the outro, because yeah, it has been going on for a while, and we're pretty much done. All right, Cootsie, hello, since your first time chatting, and goodbye since I'm about to end the stream. But yeah, I am extremely happy with how all of this went. I think we've made some fantastic progress. Really, seriously, I'm super happy about this progress. I look forward to coming back at this Wednesday after having a chance to sit down and more logically go through the code rather than just trying to get functionality quickly. It'll be much cleaner, and it will work out well, I think. I'm going to look into, like I said, the stuff to make the output a little bit prettier, because that's the kind of thing that's difficult to do on stream. Got to decide on formats and all that stuff. But logging, critical, getting as much data as possible, critical. So I want to do all of that. So we'll be trying to do that. And then, yeah, Wednesday, we will be right back at this. And something I didn't mention for this whole stream, this was the stream that will have got me partner. So that's kind of cool. This will now be the 12th stream in the last 30 days, and that's the last requirement I had to meet. There are so many of you who like to come and check out these streams that I've really blown all of the other stats out of the water. It was just on me, so I will be applying for that after all the numbers roll in. But yeah, so Wednesday I will probably have filled in the application for that. So yeah, all right. If you're watching this on YouTube with the VOD, you can come over to the Twitch channel and have some fun with us live. The link is in the description. And if you enjoyed this, you might want to subscribe either there or here. That means different things in different places though, so just so you know. If you want to support the channel and get cool shirts like this one, but that is it for the moment, and I will see you next time. Oh no, I just filmed the new printout today. I haven't had a chance to edit it, so this is gonna be another April one, but oh well.